Okay, so then we start. First of all, I have to say that this dissertation will be recorded, so that everyone is aware of that also. And welcome to this dissertation by Johan Karlsson, and he's defending his thesis, Livestock as Resource Users and Landscape Managers, a Food Systems Perspective. And first I would like to just go through the procedure of the dissertation. So first we start with the respondent, Johan, that will present his work for approximately half an hour. And after that, we leave the word to the opponent to put the thesis into an international perspective and put it into a general perspective. And when that is done, we leave the floor to both the respondent and the opponent to discuss the PhD thesis for as long as they like. But what we say that after 1.5 hours, so approximately 2:30, we will have a break. So independent of where we are in the discussion, but we don't break in a question, but we try to fit it somewhere around after 1.5 hours. So everyone has a chance of refreshing a bit and also giving the opponent and the respondent a chance of sort of catching their thoughts a bit and restart. So and then after 10 minutes we continue. And when the opponent is finished with the discussion, then we opening the floor for the evaluation committee to have questions and discussions. And after that, then we also leave the floor for the audience, first in this room, and then we also have an opportunity for the people online to ask questions. And if you are online and want to ask a question, then you have to raise your hand and write a message that you have a question. And then we can actually give you the electronic microphone to ask the question. Or you can ask Elin to say the question. And when we have had all the questions answered, we will close this session. And the evaluation committee will have a closed meeting regarding the grade of the thesis. And the grades available is pass or fail. And attending this meeting until the decision is taken, the opponent and the supervisors are joining the discussion to give their views of the thesis and of the work of Johan. So now when we have the procedure, then we have to introduce everyone that is taking part in this defense. I am Professor Björn Winnerås, and I'm head of the Department of Energy and Technology, and I have been appointed by the faculty to be chairman of this session. And we have the opponent, Dr. Pierre-Marie Aubert, that is coordinator of the European Agriculture Initiative at IDDRI in Paris, in France. Welcome. It's nice to see you in the room, and not only electronic, I would say. It's a great shift back. And also in this room, we have Associate Professor Johan Groth from Farming Systems Ecology Group at Wageningen University and Research at Wageningen in the Netherlands. And then online, we have Professor Jenny McMahon, sorry for my poor pronunciation.
It's okay.
At the Institute of Applied Health Science, University of Aberdeen, King's College in Aberdeen in United Kingdom. And we have Robin Harder at the Federal Department of Economic Affairs, Education and Research, Agriscope in Zurich, Switzerland. Also online. Hope to see you. There you are. Yeah. And then we have the supervisors also of the work. We have the main supervisor, Professor Per-Anders Hansson. And we have the deputy supervisor, Associate Professor Elin Rös, both from our department also. And now to the reason why we're here. It's a long introduction, but now we're here. Johan Karlsson. He holds a Master of Science in Environmental and Water Engineering from Uppsala University. And he said that he has no errata to show, so then I don't ask that question. But then I leave the floor to you to start your presentation.
Thank you, Björn, for that thorough introduction.
And welcome all of you who are here in the room, and also those of you who are participating online. So I will present my thesis for you today. And as you might be able to tell from the title, my thesis is about farm animals and their role in our food systems. Livestock have been an integral part of human societies and agriculture pretty much since humans started farming more than 10,000 years ago. And historically, livestock were often important in making use of resources otherwise unavailable for food production through, for example, harnessing biomass from fallows or marginal lands. Today, production is driven by demand for animal source foods. And alongside with population growth and increasing wealth, this demand has increased rapidly, with, for example, a doubling in global per capita meat consumption since the 1960s. So animal source food therefore plays a big part in our diets and nutrition globally. For example, 1/3 of all protein consumed is consumed in the form of different animal source foods. And in the European Union, that figure exceeds 50% of the protein. Animal source foods are also important for various micronutrients. For example, calcium, iron, and zinc, and vitamins A, B12, and riboflavin, which might be hard to consume in high enough quantities on completely plant-based diets. However, livestock production also comes at an environmental cost. And across most impact categories that we analyze, animal source food have higher impacts per kg edible protein produced than most plant-sourced alternatives. And livestock production is also resource use intensive. Today, around 40% of all global cropland is used to produce feed for livestock. And in the EU, that figure is almost 50%. And on top of this, large areas of grasslands are used for fodder production and grazing ruminants. And since the majority of all nutrients present in animal feed are lost as heat or manure in the animal's metabolic processes, it means that livestock production is generally a net sink for most nutrients, meaning that we get less out than we put in, so to say. And this also means that feed production competes for cropland, for the use of cropland for direct food production. And that redirecting cropland from animal feed to plant source food production could increase global calorie supply significantly. So in light of this inefficient resource use and the large environmental impacts associated with livestock production, their place in future global or future sustainable food systems have been questioned. And several global modeling studies have shown that alongside improved production practices, dietary changes towards more plant-based diets are likely instrumental in order to both reach climate targets and staying within planetary boundaries. However, while livestock do consume large quantities of human edible feeds, they also eat large quantities of human inedible feeds. And for example, in the EU, around 60% of all dry matter feed fed to animals is in the form of grass and forages that are not directly edible to humans. And livestock also eat different byproducts and wastes that are not fit or wanted for direct human consumption. And although there are other uses of these biomaterials, such as for bioenergy production, they might be potentially lost from the food system if not used to feed animals. So, and in the thesis, I refer to these types of biomass that have no other use in the food system than to feed animals, leftover resources. So if we would be limiting livestock to only consuming such leftover resources, they could potentially move from the present situation of being a net sink for nutrients to becoming a net source. And apart from this potential role in upcycling leftover resources, livestock can also play an important role in managing agricultural landscapes, supplying ecosystem services. So, for example, the semi-natural grasslands of Europe have developed over hundreds of years of livestock production with haymaking and grazing, and are today one of the most biodiverse habitats in Europe. livestock production can also incentivize crop rotations, including forage crops, that can benefit the cropping system by fixing nitrogen from the air and preventing problems with pests and weeds, which could limit the need to use chemical plant protection and fertilizers. So to balance these positive and negative contributions of livestock to society and guide policy and other actors in the food system on the livestock issue, more insights are needed into the role of livestock as resource users and landscape managers. So the objectives of this thesis were to develop scenarios where food-feed competition is reduced or completely eliminated, and study such scenarios in terms of how much animal source food would be possible to produce, and also which types of animals are optimal at converting these leftover resources into nutritious food, as well as how such scenarios would affect diets and nutrition and environmental impacts. A second objective were to assess the role of livestock in managing landscapes and ecosystem services. And more specifically, I asked the question, do farms with livestock differ from farms without livestock in terms of ecosystem services other than the direct production of food? And these objectives were pursued in 4 papers that to a varying degree focus on the role of livestock as resource users and landscape managers. But I will start off from a resource use perspective, where the role of livestock is to supply as much nutritious food from available resources. So in the first 2 papers of the thesis, scenarios are presented for a future Nordic food system, which were explored in participation with a group of Nordic NGOs. And this was done through a number of workshops where the NGOs got to define their future food vision for a food system in the Nordic region and make all the normative decisions behind these scenarios. And we as researchers were then responsible for translating these normative decisions into quantitative model inputs so we could study the effects of the scenarios on diets and nutrition, land use, and environmental impacts. And the food vision as sketched out by the NGOs was one of local food production, where the majority of food is produced within the Nordic region. The scenarios should also aim for diets that meet Nordic nutrition recommendations. And all food production within the Nordic region should be produced organically with organic farming. Agriculture should also in the scenarios be fossil-free. And here we relied on some biomass from the agricultural systems to be used for bioenergy production to cover all the on-farm energy needs. And livestock should be limited strictly to leftover resources. And in the thesis, I grouped leftover resources into 3 broad groups, which are presented here in the figure. So the first group here to the left, I call land use leftovers. And here I refer to land areas where direct plant source food production is unfeasible. So in these scenarios, we included semi-natural grasslands as a land use leftover, and also some remote forests and alpine pastures in Norway. The second category I call byproducts and waste. And this refers to biomass that is generated in the food system but not wanted for or fit for direct human consumption. So this could, for example, include wheat bran from when we mill wheat into wheat flour, so we can feed this wheat bran to animals without competing with direct food uses. And finally, since we were considering organic crop production in these scenarios, we assumed that we would need to incorporate grass legume leys into the crop rotation on at least 1/3 of all arable land. And this is in order to supply nitrogen to the succeeding crops and also to prevent problems with pests and weeds. And since the cultivation of ley is sort of, that the cropping system depends on this, but the biomass from the ley cultivation is not directly edible for humans. We also consider this as a leftover from the cropping system and refer to these as cropping system leftovers. And another binding constraint of the scenarios was that they should include enough grazing animals to graze all the semi-natural grasslands in the Nordic region to preserve the biodiversity values that are there. So here we consider two different scenarios. We call the first one sufficiency, or SY. And here we limited the number of ruminant animals to the minimum number needed to graze all the semi-natural grasslands. And these animals would need some winter feed and thereby use some of this ley biomass produced. But the most of the ley that was included in the crop rotations was not used in this scenario. So therefore, we also considered a second scenario where we allowed the number of animals to increase to make full use of all these cropping system leftovers that are generated. And in this scenario, we also included some pastures in alpine and forested areas in Norway. And across both these scenarios, the number of different animals and the distribution of different leftover feeds to them were optimized in order to maximize the number of diets that could be provided from the Nordic land base. So the results showed that the scenarios could support a large population in the Nordic region, exceeding the projected 2030 population, despite the switch to organic farming, which means lower yields and that we devote a large area of cropland to ley cultivation. But this did, however, also imply large dietary changes, most notably a strong reduction in meat consumption, with across the two scenarios between 80 to 90% reduction compared to current consumption levels. And we saw in the scenarios that ruminant meat and dairy production was favored over the production of pig and poultry meat, since the ruminant animals can utilize this biomass from the ley cultivation that we needed to include in the crop rotations. And looking at the diets, they had both nutritional benefits and challenges. So on the negative side, both scenario diets exceeded the recommended carbohydrate content of the diet. And the SY scenario, including less animal source food, did not meet recommendations for calcium, vitamin A, B12, and riboflavin. While the efficiency scenario, which included slightly higher animal source food consumption, only failed to meet recommendations for carbohydrates and vitamin A. But on the positive side, both diets were lower in saturated fats and contained more dietary fiber and folic acid. And so that's the diet part. Going to the production agriculture part, we saw that the scenarios would imply a much diversified agricultural production in the Nordic region, going from a focus on cereals and ley cultivation, which is the present situation, to growing much more vegetables, legumes, and rapeseed. And we actually saw in the scenarios that producing enough rapeseed to meet the minimum requirements of fat in the diet was limiting the productivity of the scenarios. So in order to not cultivate rapeseed too frequently, which can cause problem with buildup of soil pathogens, more ley cultivation or other crops would need to be included in the crop rotations. So producing enough fat was a limiting factor in these scenarios. And moving to the environmental impacts, this figure shows the impacts of the two scenarios in relation to suggested planetary boundaries expressed on a per capita basis based on the projected population for 2030. And these are shown for climate impact, the addition of new nitrogen and phosphorus, as well as cropland use. And what I want you to mainly see here is that we could see a trade-off between minimizing greenhouse gas emissions and cropland use. So in the second scenario, EY, where we had more livestock that could utilize this ley biomass that was in the system, led to a lower cropland use. The larger number of ruminant animals also led to more emissions of methane, which increased the climate impact of this scenario. I also put in figures here from a recent study by a colleague of mine here at SLU, And while these studies are not directly comparable method-wise, I think it still clearly shows that this type of scenarios would considerably reduce both greenhouse gas emission and cropland use, despite the switch to organic farming, which means lower yields. However, in both scenarios, we could see nitrogen and phosphorus deficits. And this was despite that more than 1/3 of all arable land was devoted to grass legume lays that fixed nitrogen from the air, and that we included quite optimistic assumptions on the circulation of nutrients from society, from manure and food waste. Potentially to remedy these deficits, further increased recirculation could be considered, for example, by recirculating urine and feces from society. But even doing so, the systems would likely need to rely on other external sources to supply enough nitrogen and phosphorus to the soils. So while these first Nordic scenarios that I've talked about now represent a situation where livestock are strictly limited to leftover resources, this second set of scenarios, which are presented in paper 3, represent a potential first step towards reducing food feed competition. So here we consider the case of ceasing soybean feed imports into the European Union. And this case was selected as reduced soybean imports is already on the political agenda for a number of reasons. First of all, import dependency is seen as a food security risk, making the Union vulnerable to volatile global markets and potential trade restrictions. Soybean production is also associated with environmental impacts, mainly related to deforestation in South America. Soybean, if used as a plant-sourced food, is also nutritious, containing both protein, fat, and essential amino acids, all of which are important if we consider diets with less animal source food. So here we considered 3 different scenarios that reflect different uses of EU cropland. But in all these scenarios, the total use of cropland within Europe was kept unchanged to avoid that we would encroach on areas that are currently used to produce crops for other purposes. But the scenarios entailed a different use of the cropland that is currently used to produce animal feed. And all of these scenarios also supplied the same amount of protein and fat to diets. And this was achieved by assuming that we would continue to import some soybean, but use it directly for food instead of animal feed. The scenarios also maintain the supply of vegetable oil to global markets. And this is important because the majority of soybean that is fed to animals is fed in the form of soybean meal. And here we have extracted the oil from the meal, and the oil is traded on the global market for vegetable oils and used for food or bioenergy. So here we consider that this reduced production of soybean oil would need to be compensated for by increased production of palm oil, which is the oil, the currently marginal oil in global trade, and the most likely candidate to replace this. And similarly to the Nordic scenarios, we use an optimization model to find the number and types of ruminants and the distribution of different feeds that would optimize the production of animal protein in the scenarios. So looking at the results, we saw that in the scenarios, the demand for cropland outside the European Union was reduced by 11 to 14 million hectares. And these are really large figures. And to put them into perspective, this approximately equates to the entire cropland area of Germany or Spain, really big countries in Europe, or the entire land area of Iceland. And similarly to the Nordic scenario, the optimization model favored ruminant meat and milk production, since also here a lot of biomass from permanent grasslands and other forage crops were available, which favored these production systems. But we could also see that egg production was favored in the optimization model. And here it's because this mode of production is very efficient in producing human edible protein. But while the land use outside Europe decreased in all scenarios, we could see a trade-off between a lower cropland demand in South America, but a higher demand in Southeast Asia. And both these regions are associated with deforestation and loss of biodiversity. So here there might be a trade-off where we only shift burdens and impacts from one region to another. And it was only in a scenario where we assumed that we would produce more vegetable oils in Europe where this trade-off could be avoided. And we actually saw in all scenarios that more cropland was needed to produce this additional fat that was lost in the form of reduced production of soybean oil and less animal source fat. So more land was needed to produce this additional fat than the additional protein that was needed. And I will now move on to the second focus area of my thesis, the role of livestock in shaping agricultural landscapes and associated ecosystem services. And to study this, we developed a framework with 7 different indicators relating to different ecosystem services. And in this presentation, I will focus on 4 of these indicators. And what I show here is the indicators we assessed and how we assumed that they would relate to different ecosystem services. And I will briefly go through them. So we had one indicator called landscape variation. And here a farm with smaller fields, irregularly shaped, perhaps dispersed in a forest landscape would receive a higher score than a farm in a more monotonous cropland landscape. Then we have an indicator for the amount of semi-natural grasslands on the farm. And as I've previously stated, these are one of the most biodiverse habitats we have and relate to ecosystem services such as providing habitat for pollinating and other beneficial insects, but also to cultural services such as supporting our cultural identities and providing nature recreation areas. We also had an indicators for crop sequences, so the order of different crops grown on a farm. And here, if farms grew a mix of different crops with a large diversity, they would receive a higher score on this indicator. And also farms that included more lay cultivation would receive a higher score, as these crop rotations are beneficial, for example, nitrogen fixation and preventing pest and weed problems. And we also tried to count the number of visitors at the different farms. And here we relied on 2 different data sources, both photo uploads to Flickr and also species observations to the publicly available species observation portal called Artportalen. And we assumed that this indicator would relate to ecosystem services related to nature recreation. And all of these indicators were calculated for a large subset of Swedish farms, covering more than 80% of the total agricultural area. And all of the farms were categorized as being of a specific type based on the Swedish typology of farms. So each farm was categorized as either specializing in crop production, ruminant production, pig or poultry, or being a small-scale farm, for instance. And since Sweden is very heterogeneous and the natural preconditions in different areas would lead to different scores on these indicators, we wanted to study how farms differ from each other depending on the type on a more smaller spatial scale. So therefore, we always compared different farms of different types to neighboring crop production farms within a 20-kilometer radius, where one can assume that natural preconditions are at least more similar. So looking at the results, we can first observe some clear geographic patterns. So the blue areas are higher scores on the indicator. And we can see that these forest-dominated landscapes receive a higher score on this indicator compared to the agriculturally dominated regions of Sweden. And for the semi-natural grasslands, we can see a clear hotspot in south-central Sweden and also on the island of Öland. And for the crop sequence indicator, we can see that the agriculturally dominated regions of central Sweden receive a lower score, while the increased inclusion of lay in crop sequences in the forested areas give a higher score there. And we also could see that the southernmost parts of Sweden where not a lot of ley is grown, receives a higher score due to the larger diversity of crops grown there. For the visitors, the results were a bit more scattered, but we could see some hotspots close to the urban centers and also along the coasts. But looking at the comparison across farm types, we could see that farms with ruminants and also with horses were associated with more varied landscapes, more semi-natural grasslands, which is sort of a given, but also better crop sequences and more small-scale habitats. Regarding this indicator for visitors and the other indicator we had relating mainly to cultural ecosystem services, here results were less conclusive, and we didn't find differences that were of a sort of considerable effect size. So while ruminants were positively associated, we could not find any positive association with farms focusing on pig or poultry production compared to crop production farms on any of the indicators we assessed. So I'll now provide some more general discussions and summarize some of the main results from our work. So first of all, from the two scenario studies, we could see that scenarios where we limited the use of food competing feeds led to a favoring of ruminant animals, since these animals could utilize the forage biomass that was available in both of these scenarios. We also saw a potential trade-off between minimizing cropland use or greenhouse gas emissions. In the Nordics organic scenarios, we introduced the concept of cropping system leftovers, and we found it to be valuable and important, as such cropping systems do generate considerable amount of biomass that is not directly available for food production. In the thesis, I also discussed the potential problems of defining what is a land use leftover, so which areas are unfeasible to produce crops on. And here I argue that as this is so much depending on the amount of resources we are willing to put in to a piece of land, it makes it very hard to draw the line. So instead, I argue for employing a land use manager perspective in defining land use leftovers as areas where grazing livestock can actually make a positive contribution to biodiversity conservation and ecosystem services, instead of trying to find a definition from a strict resource use perspective. In both scenarios, we also saw that unlike the common focal point, which is protein when we talk about diet with less animal source foods, we saw that fat is equally or perhaps even more important to focus on. And this is perhaps logical, considering that livestock are generally a net source for fat, meaning that they produce more animal fats than the plant fats that they eat, but often a sink for protein. And it's also important here to consider that demand from other sectors, such as for bioenergy production, is quite large for fat, but protein is mainly only demanded in the food system. And looking at the results from the landscape manager perspective, we saw that farms focusing on ruminant production were positively associated with several of the indicators we analyzed. But there were also large variation within individual farms. And our results can't be taken as showing any causal links, so further research would be needed here to identify farms and practices that can promote ecosystem services in the best way. And as I said, the results for cultural ecosystem services were less conclusive, but we did see a clear pattern when it came to the semi-natural grasslands, in that they attracted much more visitors according to both the data sets we used compared to all other agricultural land uses. So to wrap this up, I bring you back to where we started, and we'll try to point out the main conclusions and what I hope I have learned with this. So we saw that there are potential trade-offs between minimizing cropland use and greenhouse gas emissions. We also saw that it's important to focus on fat and not only protein. We saw that cropping system leftovers is an important concept to focus on, and also that the definition of land use leftovers might benefit from employing a landscape manager perspective. And we saw that farms with ruminants were positively associated with several of the indicators for ecosystem services. And we saw that semi-natural grasslands were related to cultural ecosystem services. But we did also see that the lay production that is seen as beneficial here on the ruminant animal farms were often not well integrated into the cropping system, which means that some of these potential positive effects of cultivating lay are not currently realized. So while this thesis does not provide a definitive answer on what role livestock should play in future sustainable food systems, I hope that it can guide policymakers and other actors in the food system on this challenging task of balancing the positive contributions of livestock against the urgent need to reduce their negative impacts. And with that, I say thank you.
Thank you very much, Johan. So now we invite the other named person at this. So, Dr. Aubert, please.
Thank you very much. Thank you, Johan. Thank you, Mr. Chairman. Good afternoon, everyone. Very happy to be here. Thanks to Eileen for the invitation. So I have the difficult task to do something I've never done before, because the French system is totally different from what you have here in Sweden. But I'll try to do it as best as I can. So your thesis, Johan, tackles, as you said, in the conclusion, a very key topic for the sustainability of our food system, that of the role of livestock. And as you said, in the resolution, we need to, at the same time, decrease its considerable impact on the environment and maximize the benefits it can offer. So before discussing the contents of what you've presented, I just would like to say a few words on the quality of the manuscript and the enormous effort you put in bringing together the 4 papers that are quite different in one single manuscript, trying to put in perspective the methods used in the different papers and putting the different papers into a broader perspective. So that was really, really appreciated, on my side at least. And it was a highly coherent manuscript. I would recommend it to all my PhD students, I should say. So thank you for that. It was really a good read for me. Now turning to the contents, I'd first like to point the fact that it's amazing the set of data you've collected at different levels, ranging from the farm to the Nordic region to the EU level, and even with consequences for the world food system. So that's really impressive. I don't know how long it takes you to carry all that out, but I should say it's probably the first time I see as a comprehensive PhD thesis. So thank you for that again. Now, digging more into the content and what I believe, or at least from my point of view, are the main achievements of the thesis. Maybe saying a few words regarding where I'm speaking from. I was an academic, a pure academic, I should say, but I'm now working in a think tank. So my daily work is to, of course, continue developing knowledge and doing science, but also to use that science to influence the policy process. So I'm going to put your thesis in perspective, keeping that in mind. So the fact that I'm using and doing science in the perspective of feeding the policy, the public debate, that has sort of importance. So as you pointed out in the conclusion, for me, and I agree with you, the key originality of your paper is really to propose a conceptual clarification regarding what we can call livestock and leftover, and you distinguish between the land use leftover, cropping system leftover, waste leftover, and you introduce this cropping system leftover sub-concept, if I may. And it's really interesting, as you said, it's used to explore the tensions between managing resources and managing landscapes. So making the best use of resources and offering the best to a society through ecosystem services by managing landscapes. And in other words, that that is a way for you, or at least it's how I read the thesis, to explore the trade-offs between what will be an efficient or sustainable use of resources and what is an efficient or sustainable use of the landscapes. And as you said at the end, those are two different things with potentially trade-offs, but also synergies. I have a last word on the overarching framework of your thesis before discussing the key results. One thing that I really appreciated, I already said that in a way, is the fact that you really try to combine temporal and spatial scales in your analysis. Regarding spatial scale, I said that from the farm to the EU and even consequences for the world food system. And on temporal scale, you at the same time analyze current systems and how they are organized and potential future systems. Here, one thing we will come back on during the discussion is the fact that you could have tried to make better connections between what you observe today and what you project for the future. And basically, to what extent could the farms you have observed transition towards the sort of farming systems that are sort of embedded in your scenarios? This might have add to your manuscript, even though you have already done a lot. And last point on the framework again is that you really try to take a systemic and multidimensional approach, bringing together different environmental issues, following loosely, but following nevertheless the planetary boundaries framework, and leaving aside, but making it explicit, socioeconomic dimensions. That is something on which I will come back during the discussion as well. So now coming to the results, and what I consider, at least from the think tank point of view I'm talking from, are the main strengths or the main achievements of the work presented. Not to make a play of word, but it really feeds the debate on what livestock systems would be best appropriate to minimize the environmental impact, and in particular, with respect to one key tension I'm experiencing on an everyday basis between monogastrics intensive systems versus ruminant extensive systems. It might seem a bit technical, but it's really something that is at the heart of many debates in Brussels, in Paris, in Berlin, wherever we are discussing with policymakers on what to do with our livestock for the future. So what you demonstrate in your thesis, or at least what I take forward, what I ram home, is demonstration that, given the framework I've explained, extensive ruminant systems are key to valorize leftover in a circular economy perspective, even though you don't necessarily emphasize this concept of circular economy, and that at the same time, those extensive ruminant systems are the best place to provide non-provisioning ecosystem services through their role as landscape managers. And you clearly flag that they do that in a much better way than monogastric can do, even though those monogastrics can play a role in recycling nutrients, etc., etc. So what I said, why do I believe this is fairly important, why I believe this thesis will be very important in the next few months and years, at least for me, and I'm going to use it. As I said, this is a fairly important point in a context where the debates, the food system debate, at least the ones I'm contributing to, is dominated or are dominated by climate issues. And through that lens, what comes out from many researches, what is said by many stakeholders as well, is that intensive monogastric systems should be preferred over extensive ruminant ones. That at least what you hear everywhere in Copa-Cogeca, whatever. And ruminants are considered as basically the enemy of the climate. You can see that everywhere. Don't eat red meat, don't eat beef, don't drink milk, da-da-da. And it is often said that they should only remain as marginal as possible given their high climate impact. And at the same time, permanent grasslands that are the natural source of feed for ruminants might be considered, or are sometimes considered in some papers, as free space that can be used for whatever, afforestation, producing biofuel, rewilding, etc. So, in the same time, your work corroborate or go in the same direction than others, the ones that you very well cite, Vansel, Shader, et al., the work we did at IDRI on agriculture in Europe. This is well discussed in the thesis. What is less discussed in your thesis is what I would call the other stream of literature that focuses on intensive monogastric systems as the best way to tackle climate change, or intensive systems in general. So the system identification stream of literature more broadly, with authors like Tim Suchiger, Andrew Banford, etc., that really points out to the need to intensify systems, to increase the per unit of food efficiency, etc. You don't discuss that much. We will come back to that in the discussion, but I think you would have had the opportunity to engage more with that kind of literature. Another key result of the thesis, here again in full coherence with other previous work, with most of the work I know at least, is that while relying on leftover for livestock systems is a way to increase the land use efficiency and to generate various ecosystem services, it presents various challenges. It enters to some extent, and you said that very well in your document, in your presentation, with climate objectives. There is a trade-off between both, between maximizing land use efficiency or maximizing climate efficiency. And it leads to reducing the amount of animal source food that can be produced by a given food system, which has implications for diets, and in turn, or at least for the quantity produced, and then for diets or consumer practices, not only at the regional level you're looking at for the EU, for Nordic regions, but potentially for also the rest of the world, with the European Union in your EU-S scenarios not being able to export as much animal source food that it used to, or it does at the moment. And you will find authors, I mean, I can cite some of them, I've been discussing that for hours with them, that will tell you that the role of the European Union now is to be able to export as much climate-efficient meat and animal source food to the rest of the world, while your scenario says basically not the contrary, but that, well, if we want to maximize the land use and the efficiency, then we might need to limit our ability to export animal source food to the rest of the world. So that's, again, goes back to the tensions I mentioned earlier. So to conclude this first round of comments, I'd say that for me, the thesis you present clearly demonstrates your ability to contribute to important debates with very solid scientific evidence. So I'd be very happy to confirm your ability to become a full researcher. And there are 4 points that I'd like to address during the discussion. And let me announce them right now before maybe leaving you a few time for reactions on what I've just said. I will quickly sketch them, and then we will detail them in the discussion. First, I'll go from the most technical to the broadest part of the discussion. On the technical side of the story, you developed very interesting modeling tools that are much more precise than what we did at IDRI, I should say. But still, I have a few questions regarding parent grasslands. And at the same time, what role those parent grasslands might play in the nutrient balance, which is not really well explored in the document. Maybe you have done some other stuff aside from the thesis, but I'd like to explore that in more details, and also the role of permanent grasslands for biodiversity preservation, not only where they are located right now, but more broadly by thinking about, okay, in areas where there are today 3% of permanent grasslands, would it be credible to say, I want 10% rather than 3%? So thinking in terms of redeployment of permanent grasslands. So this is my first point on the modeling side of the story. Second is more on the broader implications of your scenario. I will elaborate further, but given what I've said on the key debate regarding ruminants, monogastrics, and intensive extensive systems, what do you want your reader to ram home from your thesis? Are there some non-regret options that you would like him or her to ram home regarding the fact that there are controversies? We need to act now. I mean, IPCC, as you said, we have 3 years to act. What can we do? If we are just discussing between us, then we have a problem in 3 years. We already have problems. So we'd like to discuss that with you. And the third point is more about putting your thesis in a broader perspective. You explain you have explored biophysical option space, of biophysical spaces for the livestock. I'm keen on offering you or providing you some ideas on how to complement your work with an analysis of the socioeconomic option spaces and how to do that. And I'd like to hear you on some suggestions I might have, should you have 3 years more to work on the same topic. So that is all for the first round of reaction. And Mr. Chairman, I give you back the floor.
Yeah, thank you very much for this. And now we will have, when we have both Johan's perspective and we have the perspective from the opponent, then we leave the floor to you. So you can ask you to come up and then have the discussion. And then we look forward to hear.
Okay, thank you. So back to you.
Thank you.
Yeah, do you want to react on this first bunch of
these three?
On the three, I will elaborate on the 3 big points. I will elaborate now, but maybe on the rest, I don't know. I can just be more precise on the questions I have. Might be better.
However, I could give a short stab on
Go ahead.
Yeah, regarding your first, you talked about this, what I usually call semi-natural grasslands, but you refer to as permanent grasslands. And yeah, for me, those distinctions are really complex and hard to exactly what we talk about. But I will use the term semi-natural grassland as it's what I am familiar with. Yeah, so there in the Nordic scenarios, we use the current area, and it's often stated in the conservation literature that this area is far too small. So we would need to quite drastically actually increase this area. And there are, yeah, there are different estimates on how much, but and there are also different potential sort of source areas. We have some that in Sweden are called ley, but it's fairly permanent. So in the rest of Europe would be called permanent grasslands. And these could be, with the right management, transitioning towards some biodiversity states similar to those found in semi-natural grasslands. And I think you were going for something else, but I'll leave it at that for now. And this debate versus the intensive monogastric systems with pigs and poultry versus the ruminant systems on grass. It's very, like, from my point of view, my opinion is sort of that in these ruminant systems we find a lot of positive aspects. So their ability to utilize these leftover resources and their ability to support landscapes that provide things we want, biodiversity and other services, while that is not true often for the monogastric animals, even though they can provide some of these services. But so for me, but then, as you say, the climate or resource use impacts are larger for the ruminant systems. But I think that is only true when you compare ruminant animals against monogastric animals. But if you bring also plant source food into the picture, then sort of the positive of the monogastric meat gets lost, because plant source food has an even lower climate impact. So here I think it's better to sort of switch the monogastric meat to plant source foods and then afford some climate impact due to ruminant animals, so that we can get these services that they can provide. So that's sort of my take on that debate. And yeah, as you say, the socioeconomic aspects I intentionally don't go there so much, as it's, for one part, a bit outside my field as a background as an engineer. But I find it really interesting, and it's really important with these scenarios. We can of course sketch out a perfect world, but how do we get there, and how do we get there fairly? And yeah, I found your recent paper on the French dairy. I guess you might talk about that a bit here, where you try to sort of see, okay, here is where we want to biophysically get, but how can we do that in a fair way. I found that perspective very interesting.
Great.
Yeah.
Thank you for those first reactions. Maybe let me go into some level of details. I'll try not to be too technical. Apologize in advance if it is. So I'll start with a couple of questions on nitrogen balance, which is a matter of concern for many of us, I believe. So your food Nordic diet scenarios are at the same time, it was a bit puzzling for me. There is at the same time a shortage in nitrogen, and it was first, but an over-utilization of nitrogen compared to the Hitler-set planetary boundaries, or at least how the Hitler-set. I was just wondering how is it possible that it exceeds the planetary boundaries set by the Hitler-set, while in the Hitler-set scenarios, and I've got the disaggregated data by Springman, they are using quite some synthetic fertilizers. So I was just wondering how is it possible to exceed the nitrogen PB while not using any synthetic nitrogen. I was like, what were your nitrogen use efficiency assumptions? What was the yield response curve to nitrogen? I was like, oh, how is it possible? This is the first big technical question.
Yeah, I will try to answer now. The display, can I trying to show one of the figures from the thesis, but I can start talking.
Yeah.
So one part is that, like, while the majority of food was produced within the Nordic region in these scenarios, we also included some imports. And these here we used factors relating to current conventional practices. So these were not produced in such circular systems as the one we modeled in the Nordic region. So this makes up a fair bit of the nitrogen and a really large part of the phosphorus footprint. So that explains part of the...
Only part for nitrogen.
Yeah,
I noticed that, but for nitrogen, it's if you subtract the part of imported, you're still above the the
exactly. Yeah, and I was myself a bit puzzled with this, but so one assumption is that we assumed the same leaching in the different Nordic countries as is currently the situation, and a switch to organic practices with lower yields and lower nitrogen additions, we might see a lower.
But so that means loss. You assume the same nitrogen use efficiency on average. Or not? Because if you assume the same level of leaching, then it means the same...
No, we assume the same per hectare kilo nitrogen loss from
So you did not sort of plug the amount of losses and leaches to the yields?
No.
Okay.
We only use one.
So yeah. I think if you apply nitrogen use efficiency, which is coherent with the fact that you are you are short in nitrogen, then the uptake of nitrogen by plants is much higher. So I'm sure you're gonna get well below the threshold. I'm quite sure of that. Well, maybe our colleague from Wageningen can elaborate a bit on that. So this was my first point. The other point I had still on the nitrogen balance was that from the data you present in the main text, it's not really easy to understand to what extent permanent grasslands or subnatural grasslands, I'm happy with both wordings, contribute to the nitrogen balance. And the question is really important for me because you refer to Pierre-Marie et al. To say, well, we see how challenging it is to close the nutrient cycle only with organic cropping systems, with no synthetic fertilizers, blah, blah, blah. And you refer to the Novak paper, on the fact that nitrogen for sure comes from conventional farms. And in Barbier's paper, the 2021, if you look at the graph, I should have prepared a slide just for that. But if you look at the nitrogen flux graph, you see that permanent grasslands are net sink of nitrogen, which for me is a bit like puzzling. So I asked the question to Pietro, and I told Pietro in TIFA, permanent grasslands of TIFA is the scenario produced. Permanent grasslands provides up to just below 20% of all the nitrogen needed, around 11.5 million tons. Because we assume those yields, so 5 tons per hectare per year, blah, 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 differentiated by regions, 25% of leguminous plants in the composition of the grassland because they are not fertilized, not sowed, And we also assumed that 60% of the manure of dairy cows could be transferred to croplands because they come back every night to the stable. So with those three variables, we were able to say, okay, that is around 19% of nitrogen coming from permanent grasslands through symbiotic fixation. And in your paper, I looked for that. I even went to the supplementary matter, etc. But I didn't see anything that could help me to understand what is the assumption, or if there is any assumption regarding how much permanent grassland or semi-natural grassland can contribute to the nitrogen balance. Just if you can.
Yeah, as we say, I don't remember the results exactly, but what we saw was that the semi-natural grasslands in the Nordic scenarios were sort of in balance. Like they didn't supply more nutrients or receive, but like the same amount of nutrients that was grazed by the animals there was also deposited in their manure, according to our calculations. And I think
as of today,
in the scenarios.
In the scenario, okay.
In the scenarios. Yeah, I haven't done that kind of calculations for the current situation.
Okay.
But I don't know, when you talk about permanent grasslands, do you also refer to permanent grasslands that are mowed or harvested or only grazed?
Well, I consider like because in France it really depends, but I consider them as being similar in a way, in the sense that in many cases you have permanent grasslands that are only grazed. Some are half grazed, half mowed. Some are only mowed, but they are rare in France, at least. So I didn't do any distinction. In TIFA, we didn't do the distinction between those different configurations.
Yeah, but so the semi-natural grasslands in the Nordic region, they are only grazed, so there's no harvesting of grass from there, which might explain sort of if you have grasslands that are both grazed and also that you harvest some, then you will get a larger nutrient pull into the stable and possibility to spread manure. So I think that is, and these semi-natural grasslands are really meager, is that an English word? Like they're producing a very low gross biomass.
Okay. So what was the yield assumption, just for me? Okay, around 2 tons or something?
Yeah, something like that, yeah. I think. Yeah.
Never mind.
Okay. Yeah, so I think that, and so sort of the vocabulary in Sweden compared to the rest of Europe is a bit strange, since in Sweden we refer to lay as, even if it's more or less permanent, we still refer to it as lay if it's on arable land. That is land that sort of have been and can be plowed, and yeah. So a lot of what is in Europe permanent grasslands is called lay in Sweden, which is so I have a bit of a maybe mixed vocabulary there. So, but if we would look at what in Sweden is called lays, and also these permanent lays, there we would probably see a larger sort of potential to harness nutrients from there. But those are also fertilized often.
Yeah,
so
at the moment, yes.
Yeah.
Okay, good. Well, just here it's more a note than a question, but you mentioned to cover the shortage in nitrogen, the potential to use cover crops or catch crops made up of leguminous crops. Again, in the scenario we developed, I think we were a bit too optimistic, but it covered just beyond 20% of all nitrogen needs. So it's quite important as well. And in Barbieri, I asked Pietro, and in Barbieri's paper, they also did not include any cover crops with legume crops, so which also explain why they are so short in nitrogen overall. But anyway, that was the most technical part of the discussion. Still on the modeling, and a little bit less technical, is, well, you already answered, so I will not come back to that, but just say a few words. You do not refer that much to the literature on semi-natural vegetation and the role it plays in landscapes overall. You refer to the fact that permanent grasslands provide a lot of ecosystem services, etc. But there is also a literature stream that basically tries to account for the fact that below 20-25% of semi-natural vegetation in agroecological landscape, some regulating ecosystem services will not be provisioned anymore. Like I'm thinking of the Guy Medi paper 2021, I'm thinking of many papers from Teja Charke. And so this points to the question that you already addressed, but which is basically around, should we not think about having more grasslands in areas where there are not enough today, not enough semi-natural vegetation, even though, as you rightly point out in your manuscript, this would mean that it's not anymore land use leftover, because we are putting grasslands on areas that can be plowed, that can be cultivated, but because we need those ecosystem services that they provide, there is a value in having them here. But anyway, this was my first block of question. Maybe on the Garibaldi and Sarnecke papers, you have something in mind or not? You have seen those papers?
I'm not entirely sure of the paper you're referring to.
Well, the Garibaldi paper is the one on the title is Towards Agro-Ecosystem that Work and the Need for X% of semi-natural vegetation within. I don't remember the title exactly. And it's more a simulation than anything else. And Sarnecke papers are those that show the relationship, the quasi-linear relationship between the amount of semi-natural vegetation and the biodiversity of different taxa and groups of species.
I was like I don't know if this is an answer to your question, but like one thing I was sort of thinking about when writing about this, the potential of sort of including a landscape manager perspective in defining land use leftovers, that I call them, is that to be able to account for this kind of thing, that there might be reason to have a grassland in a certain area that is sort of not related to like the resource use efficiency. So that using such an approach, I guess we could, if we manage to decide where and how much semi-natural vegetation we need and where it's best put, so to say, in the landscape, yeah, that's sort of a potential to bring that into this sort of conceptual framework around the livestock and leftovers concept. Or
yeah, well, we are working on that at the moment, and I'd be happy to share that work with
yeah, I can say we have an upcoming, I will continue working here. We have an upcoming project where we will try to focus on sort of what are valuable grasslands, and we will try to sort of define what we mean with grasslands that we want to preserve, and how much area and which areas, and also then later which production systems can most environmentally efficiently manage these areas. So that's a thing I hope to work on in the future also.
Great, excellent. Yeah, the second block of question is on scenarios and their broader implications. I think you already addressed partly the big question, which is what do you take from your scenarios? And you said, well, I take that ruminants extensively raised are potentially more interesting than monogastrics, even though efficiency, I just wanted to situate that discussion in the broader sort of political and scientific landscape. You don't refer at any point of your manuscript to the land sharing, land sparing debate, and I think it was intentional. Maybe you can comment on that later. But basically, your work, I clearly put your work under the heading of land sharing perspective, in the sense that you pay attention to the fact that having biodiversity within agro-ecosystems has an importance per se in itself, which is not the case of many papers, of many work that basically dominate for me the debate in which I am involved. And the climate focus leads many researchers, many works to focus on monogastrics that are intensive, and then permanent grasslands or natural grasslands are used for afforestation, biomaterial, biofuel, and in general, it provides more biomass to the rest of society for different uses. And because there are less permanent grasslands, there are also less ruminants, so GHG emissions are lowered, etc. The model, the scenarios that are developed using such an approach makes as if, at least, preserving biodiversity within farming systems is just not an issue. So they free up more land, they reduce more land. Those such scenarios converge with views on dietary shift, even though the composition of the animal source food basket is different, of course. But at least the reduction in animal proteins is a common feature to all those scenarios. The need to reduce food waste and losses, but on what farming systems and what livestock systems we need to sort of prefer or concentrate on, there is a big divergence, and this has implications as well for what cropping systems we need and how we need to integrate cropping and livestock systems. So all in all, when it comes to providing sort of direction of travel for agricultural policies, for farmers, for cooperatives, for like food value chain actors, we are a bit stuck because of this huge controversy. As I said, we are in a sort of agency, so we need to do something, we need to provide answers. So I had like 2 questions on the broader implications of your scenario. One you have already answered. Can you identify no regret options? I mean, no regret options. So things that are, whatever is the result of the controversy, needed to be done in the next weeks and months and years. And the other question is, can you identify debates that really needs to be continued? And in such debates, how do you see research, and your research in particular, but other if you have in mind, playing a role? How can research help moving on in such debates, even though we know that in those debates, they involve a lot of values and normative choices from the society, etc. So I'm not saying you're gonna make choices for society, but how do you see continuation of your work helping to solve those debates and to help society make a choice?
I think looking at least sort of Northern European perspective, I think sort of implementing policy that tries to steer dietary change is a no regret options because we consume way too much ruminant meat also. We don't need as many ruminants as we currently have in many places to supply these beneficial services. So I think there is a no regret option in promoting more plant-based diets. And regarding, you mentioned this, the land sharing, land sparing debate, which I'm also a bit surprised that I didn't mention it in the thesis. I don't know why, but it's, I think I have realized that I have perhaps a quite anthropocentric view on biodiversity. So I often see biodiversity conservation as a way to create a future that we would like to live in, rather than promoting biodiversity per se. And I guess if you are more leaning towards only wanting to promote wilderness or biodiversity at its original state, sort of, then you might lean more towards a land sparing where we produce intensively in one place and then. But for me, when I see such a future, I see these intensively cultivated landscapes where we would live. And so then sort of our benefit from the nature we conserve in these protected areas would not benefit humanity in sort of my view of it. So that is my, I don't know, philosophical entry point into this debate. And therefore, I think I'm leaning more towards this land sparing perspective. And also, I don't remember who said it now, but
yeah, the question was like regarding, I mean, what agricultural policies we need to implement, or regarding the choices to be made. I mean, right now, just to give a concrete dimension to my question, the farm to fork strategy, which is supposed to form the backbone of future agricultural policy in the European Union, does not say any single word about the livestock sector. Not a single word. If you search livestock, you don't find. So we still have a huge debate ahead of us. My question was, besides dietary, changes that you said, and I agree with you, that's a no-regret option that is clearly formulated in Farm to Fork. What do you believe your work and other works can offer to policymakers and society alike to move on or to make progresses on those debates we are afraid of opening in a way?
Yeah, I know I write sort of some things in the thesis. So for instance, supporting animals actually grazing on semi-natural grasslands, which I think increasing those supports is a no-regret option, as that is not directly related to an increased ruminant livestock production and this trade-off with greenhouse gas emissions, because I think we have so many animals that are not grazing on these pastures. So even if we increase that support, I don't think that would mean so much for the number of animals. So I think that could be a no-regret option. And also we saw some clear, I didn't talk a lot about it here, and also maybe not so much in the thesis as I was focusing on livestock, but we saw some clear effects, even more clear than the effects we saw for livestock on these ecosystem service indicators. We saw stronger effects for farm size. So I think that is also a really important thing to promote smaller farms in the common agricultural policy, and perhaps also promoting smaller fields, which are field sizes have been increasing rapidly, and there have been some recent studies quite clearly showing the relationship between field size, even irrespective of semi-natural cover around them, and biodiversity. So I think that is also important.
Okay, yeah. No, thanks for those answers. But maybe on this on the same block, but maybe a bit aside, it's more technical question. Sorry, I promised it was finished, but it's not. It's more marginal question. Well, it might not be marginal for the results, but now you said we have this trade-off between climate and cropland use because of ruminants. Mm-hmm. My question is, do you think, and you are using a GWP 100 to evaluate the climate impact of your scenario, do you believe using a GWP star metrics will change the results vis-a-vis this? Or maybe you don't know about the GWP star.
Yeah, I know about it. Okay. I say it would likely change the results, as the GWP star is based on changes from historic levels of methane emissions. So in both scenarios, in the efficiency scenario, the number of ruminants were sort of similar to the current situation, so that would result in sort of a zero, but they were also a bit less intensive, so perhaps a bit lower methane emissions compared to the current per head emissions. So there we would probably get sort of, using GWP star, we wouldn't get a strong effect of the methane. But on the other hand, the difference between the two scenarios would be sort of the same, because in the sufficiency scenario, where we would have a lot fewer animals, we would get negative numbers on the GWP star. So like the trade-off or difference between the two scenarios wouldn't change. But I also, regarding the GWP star metric, I think it's a sort of a dangerous metric, because you mix in the history, and sort of a country that historically had more livestock in the recent history, should they be allowed to continue to have many livestock just because they had it before, while a country that is developing and perhaps in dire need of increasing their animal source food consumption should not allow to increase their ruminant herd because they used to have so few? I think that is the main problem with that metric.
Interesting, yeah. Well, the thing is also that metric is used by livestock promoters to say, well, we don't need to change anything.
Yeah, and I think that is...
So it's really dangerous. But at the same time, it's also very helpful when you want to make the point that ruminants are not as dangerous as it's often said versus monogastric when it comes to climate change. Because extensively ruminants do not rely as much as monogastrics on nitrogen and then to emission and that. Anyway.
Yeah, but I don't know, I think it's the wrong sort of way to go to try to look at these climate metrics. I think it's a better way to sort of, yes, there is a climate impact associated with methane, but yes, there are also a lot of benefits associated with ruminant animals, and we need to find a way to balance these. Yeah, that's my...
Yeah, but I think that the interest of there is also value in comparing, I would say, nitrogen-based livestock with non-nitrogen-based livestock, where nitrogen tends to accumulate in the atmosphere, and you have a lot of long-term impact of using a lot of nitrogen to produce grain that is then given to animals, etc. So for me, it's really important as well to put that in perspective and to show that, yes, methane is a problematic greenhouse gas. There is no discussion on that. But the interest for me of GWP star is not to defend ruminants per se. It's rather to evaluate the impact of a scenario versus another scenario and a baseline or reference scenario, taking into account not GWP 100 that conflate everything, but rather keeping in mind the sort of relative emissions between N2O, methane, and CO2. And that's the relative importance of those three gases that makes ultimately the impact of your scenario. And so still having some methane might not be as important as it is said if you have reduced by large and far emission of N2O. And that is what GWP star helps to shed light on in a way. But I agree with you on the dangers of using that. So.
Yeah. Of course, it's of course also important to think about these metrics and what they say, and like they are all misleading in different ways, and it's just yeah.
I have a few questions before the break. May I? Okay, good. So the third sort of bucket of question is on the use of scenarios beyond the academic space. I really hope you're going to have the opportunity to present your work, and you probably already had the opportunity to present your work in academic discussions with colleagues, etc. But again, thinking from a think tank perspective, I'm also interested in what you think or what you believe, or what was your experience regarding the use of the scenarios in other spaces. Practically, I'll start with a very simple question. When you developed the food Nordic diet scenario, it was first commissioned by the Nordic Council of Ministers, and second, with the help of or with the engagement of NGOs from Nordic countries. I was just wondering, how did those stakeholders made use of your scenarios after you published them? What did you see? What did you feel? How was it used?
Yeah, I know that there was some. They had some events, and we also had like a release event of the report, and but then there was some continuation of using these scenarios. Like they produced a YouTube video with a sort of cartoonish presentation of the scenarios, and so. But I haven't seen. I don't think they have sort of extensively used them further on now still. But it sort of, yeah. So that's a bit of a pity, I think. But I think they even. But it might also be that I am not, like some of the organizations, like the farmer organizations in Norway, I am not fully sort of tuned into their work. So they might be using it more than I think also.
Would you say, I mean, given what you've just said, I have an idea of the answer, but would you say nevertheless it has helped them in a way or in another? Or like, and in which way?
I think the process was very interesting. Like, so for instance, in the scenarios, we included some leftovers used for bioenergy. And this was especially for the Danish NGOs had been working really quite strongly against like agricultural based bioenergy. So they were really sort of skeptical against this. But then after some discussions, sort of the group agreed that yes, it might be sort of okay to use some of agricultural biomass for bioenergy production, but like their sort of red line was that it should only be used to fuel the agricultural practices themselves. So that is sort of a background to why we didn't consider a scenario where the agricultural sector would supply a lot of bioenergy to society, replacing fossil fuels, which probably would have had a very positive impact on the climate calculations of that scenario. So there, like the scenarios sort of were a way for the group of NGOs to discuss, and also with us. And also we found, so here I've only presented the Nordic results, but we did sort of the calculation country-wise, and we saw that in Norway, the population in Norway couldn't be fed from Norwegian resources, since it's quite limited amount of arable land there. And one of the persons at one of the NGOs we tried to model livestock into the Norwegian remote pastures, and but we found that they were in the end sort of limited by the availability of arable land for winter fodder. So there was sort of a realization process of sort of how much food can we produce, and sort of I think it's useful, and even more useful for those in the process than the ones reading the final results.
And this is for NGOs, and what about like the policymakers that commissioned the work, or policymakers, or at least the government agency that commissioned the work, the Council of Ministers, Nordic Council of Ministers?
I don't know exactly the background to how it was commissioned, but I think it was the group of NGOs who sort of made the initiative and applied for money, maybe from the Nordic. So it wasn't commissioned in that way, I think.
Because just to put your experience in perspective, I mean, since 2018, when we had published the 10 years agroecology scenario, I mean, I presented it probably 300 times, so once a week, basically. And I've seen how it has changed part of the narrative in the public debate. In the DG Agri internal notes, you can see some references to the TIFA scenario when it was the time to elaborate, to develop the farm to fork strategy, etc. So I was just wondering whether you had like, and NGOs are not asking us to give them some material to be able to present by themselves, etc. We did that scenario for that purpose, so it's a bit different. It was less an academic enterprise than really a science to influence work. But I was just wondering whether you had such feedbacks from NGOs using it, etc.
I know that they have been using it a bit, but I'm not super well informed.
Okay, and maybe one last question before the break, which is the same question but on the theoretical side. With the IPCC or the IPBES, we are talking a lot about the science policy interfaces. And scenarios play a big role in the science policy interfaces. And the IPCC scenarios are very, well followed, or at least discussed, even though with limited policy implications. My question was, like, if you are to continue on developing scenarios and working along those lines, how do you see your role in developing scenario, in feeding those debates, the public, the policy debates? I think you've brought very interesting aspects when talking about the process in itself of building the scenarios. And maybe now if you can concentrate on using the scenarios. And how do you see your role in making the results of your scenario available for a broader public that is not only academic, to inform policy discussions? Would you see this going beyond the role of a scientist? How do you see yourself in that perspective?
I think like my opinion and practice might differ in this case a bit, but because I think we as researchers are, of course, also responsible for trying to communicate our results in the best way we can, but often fail due to a number of different reasons. But I think, so I will probably work more with scenarios in the future, and I think it's very important to communicate these to the, but now I think I sort of lost the question. There was...
No, the question was like, you have answered. I mean, you feel it's very important. How do you see, I mean, do you see it goes beyond your role as scientist or not? You said
yeah, I think it's included in the role, but I think we can also improve, and myself can improve in that regard. But I had some thread. I lost it. Sorry.
Yeah. Okay. So now we have a short break of 10 minutes. Just so people can catch their thoughts back and find their thread again. And then we continue. So 2:41. Then we start again.
And I think we don't really have this strong advocacy for the inclusive system in Sweden.
No, it's just good.
Yeah, it's not as strong here, I think.
But it's still increasing while criminal production is decreasing.
I know, it's one thing what's discussed and one thing what's happening. I mean, what's happening is still, intensification. But at least, in discussions, there's very few advocating for more poultry, more things. So I think we at least, succeeded in some way.
But is that the case also in sort of public debate in France? That people debate?
Well, the thing is that in France, the German debate is more interesting.
Okay.
Now, the French debate is polarized between, I would say, extensive ruminant promoters that have quite some importance at least in the debate. They have not so much political rights, but they are recognized by the public, etc. But they are losing farmers, the livestock, the herd is declining, etc. At the same time, promoters of the intensive poultry and pig systems have been very vocal. And between, say, 1980 and 2010, they have been very successful in sort of avoiding any regulations and continuing to get quite significant public support. And the thing is that now, so after that, because of the economic decline of the sector, I mean, if you look at the poultry sector or the pork sector, they have been hit by massive economic shocks because they are not competitive enough. And so now they have a problem of competitiveness, and so they are still asking for more support to resist. But in the poultry sector, in the pork sector, nobody wants to hear about more extensive systems. And the argument of the poultry sector is even that they have lose competitiveness because they have engaged too much in segmentation of the market. They have developed too much of semi-extensive systems that have prevented them from investing more in a very intensive system, and this is the reason why they are now way less competitive than they are German counterparts or British counterparts.
So many interesting things to discuss.
Jag gjorde en strategi på Reise igår. Jag tar den här
Hello. 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 This one is, you hear it from the, no?
Yeah.
Okay.
Yeah, that's okay. Get some water also.
Want a fruit also, or?
No, I'm fine. Okay, thanks. Jag är som lite så här lärare som ska hålla på med eleverna.
Ja, samma med alla grupper. Bara man måste hiva in dem.
Ja, svårare.
Detta kommer vara lite långt. Det är där du ryker på.
Först såg de bara Robin, och då pinnade jag själva rummet.
Ja.
Det är samma som de ser ut.
Ja, du ser hur den där liksom.
Ja, det är ganska många som hjälper presentationen. Testa kan du.
Jag får börja se om jag kan sitta där. Men den kan vi ta med.
Ja, men han
Det där känner jag nu.
jag har ju suttit där.
Vad jag gör här.
Du saknar bara på den. Ja, men jag skulle kunna vara.
Ja. Vad var det där? Det var så tre från början. Och sen
I mean,
Okay, so now we're set to continue, sort of in the second half of the defense. So please continue the discussion.
Yep. Okay, thank you. Maybe the last bucket of questions on the broader perspectives. So we've just discussed the fact that despite there are still some controversies regarding where to go regarding livestock systems, we have some key consensus on shifting diets, halving waste and losses, etc. But things are only moving very slowly. And many policymakers we are discussing with are just telling us, okay guys, your biophysical scenario are really nice, but basically they totally lack credibility because of economic constraints and so on and so forth. So I know this was not the objective of your thesis, but I just would like to put your results in a broader perspective and maybe suggest some potential options to sort of plug your results with other possibilities. Or let's assume you will have like 4 more years to develop that and some budget. So my point is basically you have understood that beyond exploring the biophysical option space of our food system, we need to explore the socio-economic option space and potentially the political option space, which is another story. I will not touch that upon. I will concentrate on the socio-economic side of the story. You start the discussion in your dissertation in a very interesting way, when you say basically, well, the food Nordic diet scenario are quite disruptive, quite radical. They entail a structural change in the food system. So let's consider that the EU-S scenarios could be a first step. So getting rid of soybean imports to feed the livestock. And yet, even that step is in fact highly challenging. And I just would like to share with you the results of a small study we did last year in France. Our ministry is really keen on, having a protein autonomy and getting rid of soybean import and and has proposed a plan to sort of double the area under leguminous plants, both grains and forage. And so we did a small study for the ministry regarding how this could be achieved by 2030. And basically, the challenges are manifold, and they start from the inputs through the farm, through the industry, and up to the consumer. And probably know most of them. I just would like to, detail it a bit. So farmers basically say, well, I have no quality seeds. I cannot grow pea, I cannot grow soybean, I cannot grow whatever, because the seeds I get, for peas, for example, I'm going to go for 2 to 3 tons per hectare per year. I need 4.5 or even 5 to have a good economic balance or to make a reward out of that. So I'm not going for that. At the same time, the same farmers will tell you, well, even though I would have good seeds, nobody will buy it. Alfalfa. Alfalfa is a good example. There are a lot of farmers who grow alfalfa. You don't need quality seeds, or at least you have them. But because in large arable crops regions, you don't have any more livestock, there is no point in growing alfalfa. Nobody will eat your alfalfa, as you rightly pointed out, when you consider this cropping system leftover. Alfalfa is a leftover when you want to supply nitrogen to your crop, but you need an outlet, or you need livestock to eat it, or a digester. But putting alfalfa in a digester is a bit complex from an economic point of view. It's not easy to valorize. So you have challenges downstream, and then you also have other challenges at the farm level when it comes to livestock farmers and livestock processors. Livestock farmers, basically, what they say is that, well, or not livestock processors, but cooperatives or seed manufacturers. Well, I'd be happy to use French feed, but what's the point? There is a $100 competitiveness, $100 difference between the soybean I can get from Brazil and the soybean I can get from you guys. So I'm not going to do that. Otherwise, my buyers, my customers will not even buy my feed. And if they do so, then the pork or the pig or the pork pig or the poultry they produce will become much more expensive, as we are seeing now with the Ukrainian crisis. So just to say that the economic dimension of transition is really key to apprehend, and that exploring the socioeconomic option space means looking at the different sort of nodes of the value chain, from farm, from the input industry to the farm, to the processing industry, and up to the consumer, because there is also a willingness to pay for consumer if you go that way. So the thing I'm sharing all this because regarding what you wrote, what you did, I think there is potentially an opportunity to elaborate on what is in your thesis, to start this discussion or to go further. When you want to, at least that's how we see this at ITRI, if you want to really start thinking about transition pathways, to sort of demonstrate or at least explore the feasibility, the credibility of the option space you have outlined, you need a very good baseline. That's a very important starting point. The work you did in the fourth paper is totally amazing. You have like, how many farms? I don't remember. So 80% of Swedish farms. It's totally amazing. Yet, you analyze them only, if I may, on the basis of the non-provisioning ecosystem services. And so you sort of lose the perspective you're offering in the first part of your thesis, which is livestock as resource users. So we don't have any idea, and I know this is probably because of statistics, but we don't have any idea regarding the feed ration of the animals, how much resources is used, etc. We might have an idea given, you know, the crop rotation systems, etc. But maybe those farms also buy external feed. How much do they buy? We don't know. And so my point is to say, should you have the opportunity to characterize in more details the feeding strategies of your farmers in the livestock farms you are documenting in your fourth paper, you could be able to sort of characterize how far they are from the sort of livestock systems that are implicitly promoted in your two first papers for the Nordic countries. So I was just wondering whether this could be something doable, whether you would feel, so even before discussing about economics, because I know this is not your field of expertise, so but from a simply biophysical point of view, there are some things that can be done that better characterize the distance to which we are from a projected desirable future regarding the current situation. So I was just wondering on that particular point, if you had ideas on how to do that, or project to do that, or whatever.
Yeah, I think like the data that we gathered in paper 4 is, as you say, quite vast, and it has a lot of possibilities with it. And like we know per farm a 7-year crop sequence, which crops they grow, and also so we could definitely use this to sort of plug in some assumed yield levels in different regions of Sweden and get what the farms produce, and with assumptions on animal diets based on these feed rations, and also what we assume they would buy in terms of feed. We could definitely make similar scenarios as the Nordic scenarios, but much better. and with a much higher level of detail. So that is definitely something. So that, yeah, like this entire thesis has been sort of a process for me where I started off from this resource use perspective with livestock limited to leftovers to a large extent, but then moved into the field of more this landscape perspective, mainly in the final paper. So like if I would have redone the thesis, I would have brought that perspective in from the beginning and yeah, try to integrate this, because I think there is potential to do some similar calculations on what is produced and how much on different farms with the data in paper 4, and also then look at different trade-offs against these ecosystem service indicators and things like that. So I think that is something I hope to be doing in the future. Yeah, it felt like it was some more question there, but maybe it wasn't. Yeah.
No. I think that for me the key point, and I will end up here. The key point is based on our research. How do we manage to sort of to design transition pathways or to outline transition pathways that make sense to stakeholders themselves? I mean, without stakeholders, without farmers, without processors, there's nothing will happen. And so the point is, how can we elaborate on your amazing data sets to bring it closer to stakeholders, if I may? Because the NGOs were, quite engaged, involved in the process, and there is a lot of reasons why they were actively engaged in that process. But now the question is for the first concerned by the scenario, the farmers, the economic actors of the food system, how can they see a value in those scenarios? How can they make something out of that? And I think we one last point maybe, bringing this last question with the former one on scenario uses. Well, there is nothing in English, sorry for that, but there is a very great PhD thesis in France regarding how to use scenario to sort of trigger collective action. And one of the key results of the thesis is based on an empirical analysis of 8 to 10 scenario exercises across France. One of the key results of the thesis is to say scenario exercises, foresight exercises, have been successful in helping stakeholders to move forward when they have given them grips to think about the present and how to, change the present with respect to a desired future. So there is a key question in, bringing together a thorough analysis of the current situation with potential first steps of transition towards something which might be very far away from now, but still desirable, or at least.
Yeah, I think from the data set, I think it would be possible to sort of try and identify farms sort of aligning with the sort of future vision you look for, and then also sort of in a more concrete way provide an example of how would such a future look on a farm, and sort of then perhaps tie in more socioeconomic data. So how viable is this farm? Is it profitable, and so on? So I think that could definitely help sort of bringing more people on board in transition, I think.
Okay, thank you so much. Mr. Chairman, back to you.
Thank you, Pierre-Marie.
Thank you, Johan.
Yeah, thank you very much for a really fruitful discussion and interesting to listen to. So now we continue with the evaluation committee, and the suggestion from my side is that we give each member of the committee so they can ask round 1, 2 questions or 2 questions each, and then we take a round, and then we take another round after that, so you have a chance of asking questions and also follow up on the discussion previously. So we start in the room.
Thank you.
It is
should
on.
be working. Maybe I have to speak in better.
Well, first of all, congratulations with finalizing your manuscript. I've read it with great interest. I think you've done very nice work. It was already mentioned by the opponent. I think this is very important work because it paves the way for future change and also puts on the agenda aspects of full organic farming, dietary adjustments, etc., which have been, well, quite difficult to discuss, I think, in the last few decades, and change is finally coming, and I think your work will contribute to that. So, yeah, I think it's crucial. I also, well, think you have processed a lot of data and done some nice analysis on that. So that is really interesting and also very fruitful. You've already had a quite big discussion on sort of the broader implications. So I think I can now take the liberty to dive a little bit deeper and to go into initially one of the chapters, and that is the fourth chapter on the link with ecosystem services. And I start with a really a minor detail, but that is an aspect that I also work on. I just want a little bit of clarification on the clustering that you have done. If I understand correctly, you have, for instance, for the types of farms, first classified them into different livestock types, basically, and then took the size of the farm as a variable to cluster on. And so you took one variable with which you cluster. And yeah, usually clustering is a multivariate technique. So my question is that indeed correct, my interpretation of the description that you give on the 7th page of that chapter? Yeah, that's the first question. Was that indeed the procedure, or was it a different procedure?
Yeah, so in the paper, like what I present in the thesis is mainly sort of the clustering based on farm type. But in the paper, we use 3 different clusterings. Yeah. And the first one, the types are based on the Swedish typology. So they were sort of predefined in the data set that we got. So, and the Swedish Board of Agriculture classifies farms based on sort of factors for standardized working hours spent on different activities. But what you're referring to, I guess, is the clustering of farms into sizes. Yes. And this is like the origin was that we saw some effects of farm size on several of these indicators that we looked at, but we found it very hard to analyze this because the data was there was so much variation and sort of a non-normality in the data. So we found it easier to analyze the different farms cluster-wise. So then we wanted a way to sort of group farms with as much similar size as possible together. Yeah. So that was why we used this kind of clustering algorithm. And as you say, we used it on just one variable at a time. So we clustered according to farm size. But I guess we could have done this multivariate like cluster on both farm size and livestock density, for instance, to get sort of a matrix of farm clusters on different positions there. But I think like what I wanted to analyze was sort of do the indicators differ on the really large farms compared to the smaller ones and so on?
Yeah, I understand. But then I could also imagine that you would say, well, I made, for instance, 5 clusters, and so I divided all the farms in those 5 categories that I sort of predefined. Why do you need a clustering algorithm if you have only one variable? That was the question.
Yeah, it was mainly a way to, because if I would sort of just subdivide the farms, so like each group would be equally many farms, for instance, so just split the data in that way, then I would end up with groups that are less homogeneous. So this way was a way to end up with groups that are as homogeneous as possible in terms of farm size. So that's why we use that method. I don't know if it's the best way, and I don't think it would have dramatically affected the conclusions if we would have just split the data set so equally many farms in the different groups. But yeah, that's we wanted as homogeneous farms as possible was the background to it.
Okay, thank you.
Thank you.
Then my second slightly detailed question is on also in the manuscript, also in the paper of paper 4, and there you have figure 4, and in figure 4G you present the relation between predicted landscape variation and observed landscape variation, right? And there you put in 2 lines. One is a dashed line, which is basically the one-to-one line, and then there is the second line, that is the solid black line. That is the linear regression between predicted and observed values. And yeah, when I look at this figure, I think, really?
Yeah, I do the same.
Because there seems to be a systematic deviation.
Yeah.
So, yeah. Was it really this line?
yeah, it's really this line. And I was also surprised. That, like, at first, I also, this is sort of, now I'm moving into statistics a bit beyond what I'm capable of. But at first, I plotted it in the opposite order, like the switch in the X and Y axis. Yeah. And then the trend line does not follow the one-to-one line. Yeah. But then I learned that the correct way is to put the observed values on the y-axis, and then it fits to the one-to-one line, which is also what like, it's a quite large data set, this, and I used, so like the 75% of data I used to fit the model is so large, so many farms, so, and sort of the model will per definition fit without bias to those farms. So it's reasonable that is the results also for the testing data set. But I also agree that it really looks like there is a bias, but sort of, yeah, when I try to look at this, it is, yeah, it's that line, but yeah, I agree that the points look like they are sort of not evenly scattered around there. But I think it's like that they are not, they are evenly scattered in the y-axis way, but not in the x-axis way. So I think that is where the optical illusion maybe comes from.
Yeah. Well, I wanted also to talk about that point of optical illusions. And that is something that I learned during my PhD. And from the color of my hair, you can see that it was quite a while ago. But then I had a colleague who was what I would call a practical mathematician, so not a very theoretical one, but a really practical one. And he taught me that this is not such a good practice to plot X and Y graphs like this, and for different reasons. Can you maybe sort of, based on what you just explained, think of the reasons why this is not such a good idea to sort of plot it like this? Do you have any suggestion? If you don't know, it's also fine.
No, please tell me.
I think there are two main things. So one is that when we look at these graphs, our mind tries to find the shortest distance between each of the points and the line. So that is basically a line perpendicular to the x to y, so relative to the dashed line. And in fact, what you should be looking at is the vertical distance, because that's the actual difference between the observation and the predicted one. And so that is a bias from the optical analysis of this one. That's why we also have difficulty in interpreting that. And the second one is that you don't see the systematic deviations so well. And the alternative is to put the residuals on the y-axis. So the differences between the observed and predicted versus the observed or versus the predicted, that doesn't matter even so much. And then you very clearly see also the systematic differences. And so that's what I wanted to share with you, but also with the audience, basically, because this happens a lot. Of course, in modeling, this is quite universal, but yeah. And there is also a paper of, I think, 4 years ago, I think in agricultural systems, that discusses this issue also in some more detail with examples. So that's, yeah. Okay.
I think for me, I think why I did it this way instead of using the residuals is that for me, this feels more intuitive.
Yeah,
but you are, of course, correct that you will get this.
Okay,
so your suggestion is to use residuals instead?
Indeed, yes, yes, that's the suggestion, yes, yes. Then I want, for the same chapter, want to go a little bit more to one of the indicators, that is the crop sequence indicator. Probably we're already expecting some questions about that, I would say. In figure 1, you present the relationships between the indicators and the ecosystem services. And well, the graph is a little bit different from what you presented just this afternoon in the presentation, because in this graph, in the manuscript, you also present solid lines for relations that are strong. And I was wondering about that relationship between the crop sequence indicator and then the ecosystem services of regulation of organisms detrimental to humans. And I found it a bit difficult to imagine what that relation sort of represented. And just sort of questions, could you explain that relationship a little bit? What kind of regulation are we talking about?
Yeah, what I was thinking about here is sort of the benefit of crop sequences to minimize the presence of weeds. Like if we include more different crop groups in a sequence, we won't get the pests and weeds associated with certain groups. So that is what I am thinking about when thinking about sort of regulating organisms detrimental, which in this case are the pests and weeds.
Okay, so rather detrimental to the cropping systems, let's say.
Yeah.
Okay, yeah. No, I was talking about, or thinking about pests and diseases for humans, if I was reading this. But it's, okay, so it's an indirect effect on the cropping system. Okay, yeah, then I understand that.
Yeah, and also with this, I was sort of struggling with this indicator because the indicator says something about, yeah, sort of regulation of pests and weeds, and also a bit about nitrogen supply through ley. But it doesn't say anything about what the crop sequence actually produce. So like a crop sequence with only ley cultivation will not produce the same thing as a crop sequence with some ley cultivation and some cereals that might be used to produce wheat flour that can be bred. Yeah, I think it's sort of challenging to interpret a high score on this indicator, because a sequence that gets a slightly lower score might be still a very good sequence and also produce more food, sort of.
Yeah, well, that is in fact the second question that I had about this indicator, that it is, yeah, a tricky one, I would say. So, and I think for two reasons. So one is that indeed leys are preferred according to this indicator. And of course, we first have to say that you sort of use this from the literature, this indicator, so you didn't sort of develop it yourself. Well, if you have more ley, you get a higher score. And of course, if you have more ley, you have to have more ruminants. So the correlation between having ruminants and root confidence indicator is quite sort of predictable in that sense. And on the other hand, of course, it is indeed that sort of two positive sides of this indicator is that if you have a diversified cropping system, you have a high score, or you can get a high score, and when you have a lot of ley in your system, you can get a high score. So, in fact, the indicator can mean two different things. So my question is, yeah, shouldn't you sort of separate those two things into two separate indicators?
Yeah, like our first sort of line of going about this was that to use crop diversity as an indicator and use the fraction of ley as another indicator. But we ended up using this one since we thought they are so kind of interrelated, and like you could sort of, yeah, I wanted to put them on the same indicator because otherwise we would see, yes, crop production farms are more diverse because they grow more different crops, and farms with ruminant animals grow more ley. Yeah, so I wanted some indicator to sort of balance these together. And I don't know if this indicator is really optimal. And I think you need to sort of think more about this and sort of what the crop sequence actually produces and sort of what is the benefit of ley cultivation. And this is something I would want to go further with, sort of these potential ecosystem services associated with ley cultivation how much of them are actually realized today. And especially like in the thesis, I have one figure that shows how much of the lay cultivation in Sweden that is now just cultivated without mixing it with other crops. But I wanted to show, maybe relating to these two different so this figure was from the supplementary materials to that paper. So here you can clearly see sort of the colors represent the score on the indicator, and here is these two separate indicators, which is the crop diversity and the amount of lay, which were the sort of two most influential variables to this sequence. So you can see that it gets a higher score when you have more lay and when you have more diverse crop rotations. And it's quite interesting sort of that here are the different farm size clusters, that they have really different sequences, but they sort of score quite similar on the indicator anyway, because the larger farms have more diverse crop rotations, but the smaller farms tend to grow more lay there. So I thought that was quite interesting, and yeah.
I can understand from your explanation and this background that could be relevant. Yeah, thank you for now, and I give the floor to other evaluators.
Yeah, okay. Thank you very much. Then we continue with Professor McDermott. If you have a few questions also.
Yes, if I can just repeat what everyone said, it's a very interesting thesis, and it's been a very interesting discussion this afternoon. So congratulations to start with. I wanted to really just come back to one of your conclusions where you said that perhaps what we're focusing on in terms of protein isn't necessarily the right focus, and I would agree with you on that, because we eat plenty of protein and there's lots of sources of protein. But you said fat should be a more important focus. I was interested in hearing more about that, because in one of your chapters, the second paper, you sort of had looked at protein and fat and said there wasn't sufficient fat, so we needed to look at other ways of achieving this. But also in Sweden, about 50% of the population is overweight or obese. So I was interested in why, out of all the nutrients, you might say that fat is the one we should focus on more to make sure there is sufficient in the diet.
I think sort of I come from mainly this more agronomic line of thought, but in this, so I can talk about these two different scenario studies. So like in the Nordic scenarios, there we sort of looked at the Nordic nutrition recommendations and saw that we sort of agronomically found it difficult to supply fat in enough quantities to meet the minimum requirements according to the Nordic nutrition recommendations, which are, I think they are a bit higher on total fat than, for instance, FAO recommendations. So yeah, and I'm not enough of a nutritionist to know sort of why the Nordic recommendations are slightly higher in fat or not. But so that was sort of, sort of the background to this was that that I found quite interesting, I don't know, merging of this agronomic difficulty of growing crops that produce a lot of fat and sort of meeting these recommendations when we reduce the amount of animal source food, and also connected to this fact that livestock generally sort of synthesize fat while they eat more protein than what is retained in the meat or milk. So it's more sort of the relationship between protein and fat, and not so much in relation to sort of other micronutrients, which might be even more important, some of them.
Yes, absolutely. I mean, what I was, sorry, go on.
Yeah, and then sort of go into the European scenarios where we see soybean imports, there we looked at scenarios that would maintain the same supply of fat, which can be questioned since we in Europe currently overconsume fat. So we would have probably been able to consider scenarios where we didn't produce so much fat to diets, and then we might have avoided some of this trade-off with more palm oil. But here it was a bit sort of the background to the study was to sort of look at, yeah, it's still very large changes, but still some kind of moving as little as possible away from the baseline in some way was sort of the backbone thinking behind that paper. So that's why we ended up using sort of having the same amount of fat instead of arguing for, okay, we don't need to produce as much fat or protein either for that reason.
Thank you. And just really following on from that, probably directly in that third paper, you had the nice graph with the different nutrients and what was supplied with the different scenarios across the 3 different scenarios with the baseline. And obviously from that, you've got slightly less vitamin A than would be required, less zinc. I think you would probably have had less iron because the requirement for iron, which you've got as 6.4, is quite low. For women, it would be around 14. So I don't know if this is an average of the population, but that's potentially a little bit low. So you might have those 3 nutrients all that are sort of less than optimal within the population. So I just wondered what your thoughts were in terms of should they be the focus rather than protein or fat, and sort of are we I guess overall we're very much in this field, we very focus on protein because we assume animals is the only source of protein, which obviously as you know isn't correct. So I just wondered if you had any sort of reflections on that, as whether or not other than fat there should be these other micronutrients that might be important to maybe focus on a little bit more.
Yeah, I try sort of in the thesis, I try, because this figure is about, so this only shows the animal source foods in the diets, and for the scenarios the sort of additional introduction of plant source foods. So we are missing here all the plant source foods that also make up some of the intake of basically all of these nutrients except B12 maybe. Yeah. So like the actual intake would be higher than for all nutrients except B12 here. So therefore I sort of, I put it this way to sort of try to bring it into perspective of sort of what we need to consume. But like after printing this thesis and getting questions, I realized that this figure is quite sort of counterintuitive in some ways, since I relate to the sort of population requirements, but I don't show the full diet, but only sort of the animal component of the diet. And also this is sort of what is produced from livestock in Europe, but we also have some trade. So this is not also like we don't consume all the livestock products that we produce, but some are exported and we import some others. Yeah, but returning to sort of your question in the thesis, I try to sort of relate a bit to sort of how are the status of these nutrients currently in Europe. And for iron, the status is poor for especially women. So, but then like from the results here, it looks like even though sort of some of the iron in animal source food is hem iron, while in plant source that is not present, and different bioavailability, the scenario still points towards that sort of, especially when we include soybean in the diet, we might actually end up with a better iron status. But then sort of clinical studies looking at different dietary patterns have shown a link between iron status and meat intake. So, but I have a hard time to sort of know what the net effect might be in terms of nutrition for iron. But then for vitamin A, we are sort of consumed it, like the changes following from these scenarios seem quite small, and we are currently in Europe on a sort of safe level regarding vitamin A supply. But in the Nordic scenarios, we saw definitely that vitamin A was perhaps the most challenging nutrient to achieve a good status with. But there it was a much stronger reduction in animal source food. And I think vitamin A is something to focus on, especially considering in poorer countries where animal source food consumption is lower. There is vitamin A deficiency and many health problems related to that.
Okay, thank you. And just really following on from the you say about vitamin A, I was interested, you've obviously looked at the land use, cropland use for animal feed, etc. How do you sort of thought about the land that perhaps could be spared and used for other crops? So for crops, sort of maybe more horticultural crops and things that may sort of fill some of those gaps in the diet.
Yeah, like we discussed some in the paper, sort of the potential to include more carrots in the diet, for instance, that can supply vitamin A. But we haven't sort of made the calculations to really show what sort of crops we could introduce that are rich in carotene or other provitamins for vitamin A. So I can't really sort of, yeah, that's why in the thesis I was a bit careful in saying that sort of it might be hard to achieve because we haven't sort of done the calculations for that.
Yeah, I think it's just really something to think about when you're thinking about the whole food system, when you're thinking about the whole diet, and you're sort of looking at land use, particularly if the scenario is to produce sort of more locally and sort of regionally, would be to sort of say there's a finite amount of land, sort of from a nutrition perspective where I come from, is also sort of what would be the optimal crops to grow, whether it goes to animal feed or sort of directly to humans. So that was really something that could be thought about maybe sort of going forward, is linking those. But I was really pleased to see that you had made the connection between production and the diet and consumption, because so often it's one side or the other. So it was very nice to see that. Can I just ask one more question for the moment? It was really around sort of the cost of these animal production systems. It's already been discussed a little bit about what does this mean for farmers, what does this mean economically? But are these farming systems going to mean that the cost of food's going to go up? And if there's less meat, which is more expensive, what sort of issues is that going to cause in terms of different income groups in Sweden? I don't know if you thought about that at all.
Yeah, not to a large extent.
Yeah, sure.
But yeah, I am not sort of well literate in economics, but sort of from my, I don't know, biophysical perspective, perhaps looking at the scenarios for Europe first. There we sort of see that the scenarios require less land and therefore less labor to work those lands. So for me, those scenarios would likely be cheaper, like the diets, since we actually use less land and have less working hours spent on those areas. So in that way, I would think they should be cheaper.
Yep.
But then again, like the sort of, I don't know, scaling, I don't know, benefits of having large production versus smaller production. but that also depends on this, like that the diets also change so that we, if the animal source food gets perhaps a bit more expensive, but the total consumption is lower. But sort of from my biophysical perspective, I have a hard time imagining that those scenarios would be more expensive if they would sort of, if the transition would be made. And regarding the Nordic scenarios, there it's more complex because there we look at organic farming, which is more labor intensive and have sort of price premiums on markets and things like that. So those might be more expensive, but yeah.
Sure.
But
I mean, it's just, I think it's, as you spoke about before, it's sort of thinking about sort of what might happen is, you know, taking these things forward. So if you were taking it, as you discussed before the break, about, you know, taking it through to policy, how might these things sort of have an impact? I think some of these things to think about would be, you know, just something useful just to sort of for the broader picture. So I'll stop there and we can move on to the next.
Okay, thank you. Then we continue with Dr. Harder, if you can.
Hi, Johan. Thank you for the thesis and the presentation so far. Like the other speakers before, I really enjoyed reading your thesis. It is very clear that you've put a lot of work into this, and you've also covered quite a few methods and quite a few aspects in the thesis. So for the first round, I would like to go back to the discussion that you and your opponent had early on between monogastric and ruminant animals. And one of the points that was taken up, that is from an efficiency point of view, that the message is white meat is better than red meat. So that's basically within intensive production systems. And that's really a message that has been hammered into consumers' minds. Don't eat red meat. And if you really have to eat meat, go for the white meat instead. On the other hand, now your results show that the extensive beef fared better than the intensive monogastric systems, which is kind of, to me, seems to be very much in line with what the grass-fed movement, regenerative agriculture, etc., have been saying all along. So my question is there a risk that if you go out with this message that consumers might get confused, like, oh, beef was bad, and now all of a sudden beef is good, and both are scientists that say it? So in a way, I'm wondering, how do you think, is it possible to get across this message, or you find this with enough nuance to kind of mitigate these risks if you think there might be a risk? So that's somewhere in this area that I'm kind of curious to hear your perspective.
Yeah, it's I think it's a pedagogical challenge to provide a nuance and still provide some clarity for consumers to be able to sort of feel comfortable in sort of trying to do the right thing. But I think so sort of what these scenarios that are so in this field of livestock on leftovers show the favoring of ruminant animals, but still they show a lowering in meat consumption in total. So I think that is the message that needs to be conveyed, that we need to reduce the consumption of meat in general, but these certain production systems might have benefits that that may sort of, but I don't think like this, I don't know, need for favoring production systems that can provide these ecosystem services and things like that. I don't think at present, at least, that consumers really can do much about that. So there, I think it's rather policy and agricultural policy that needs to promote such farms, while consumers can safely only think about sort of reducing their meat consumption, because yeah, we don't have a risk of consumers reducing their ruminant meat consumption too much, so we would lose these pastures, I don't think, because these are largely sort of maintained through agricultural support. So that's sort of the main income for those farmers managing these landscapes.
So In a sense, you're saying that there is a low risk that people eat so much less that they go below a threshold that would provide these services that you spoke about in the thesis. But on the other hand, might there be a risk that it's taken as an argument, oh, it's okay to eat beef and that it's not going down enough? Is there somewhere a risk there?
I think it's a risk, and I think it's a risk that sort of by different people with different agenda might sort of use results in different ways. So I think that's always a risk. Yeah, I think it's hard sort of to communicate sort of what I find interesting, which is these trade-offs, which are sort of maybe, I don't know, scientifically the interesting thing. And for me, sort of, I take we need to reduce or move towards more plant-based diets as sort of a given. But I think then in my sort of communication, that might get lost, this message, I think, and that might be a risk, sort of, yeah.
Good. The second aspect that I'm interested in for this round is within the scenarios that you've been working with, grasslands had a very prominent role, obviously, with the livestock and leftovers. That reminds me on a study I was involved myself a few years back in Okanagan in Canada, which was a food system design study where also grasslands had a prominent role. And I still vividly remember that we had a lot of discussions about that these grasslands are so inhomogeneous and kind of hard to grapple with. There is a lot of assumptions one needs to make. I'm just wondering whether you, as also I struggled at times a bit to find the details in some of the aspects. So I'm wondering, would you like to share some of the challenges that you faced when modeling grasslands, and also some of the assumptions or maybe shortcuts that you had to take, and whether in hindsight you would still take the same shortcuts somewhere there? Some reflections I would be interested to hear.
Yeah, like so in the Nordic scenarios, we treated the semi-natural grasslands in a quite coarse manner. So we had assumptions on sort of a yield level that could be grazed from these areas, which we applied the same across the region, basically. So those assumptions are very sort of coarse with respect to sort of the heterogeneity among these grasslands. And I think that is sort of a thing, and also regarding biodiversity conservation, sort of the management practices needed might differ quite a lot depending on what type of grassland we're talking about. And I think moving forward, this is sort of detail I want to explore more, sort of like that in some grasslands we might want to graze with different types of animals in different periods of the year, and also like the large spread in how much biomass that can be grazed from different, like some are really dry and barely producing anything, and some are sort of wet meadows producing a lot of biomass. So those are details that were not in the Nordic study. So there we had a quite coarse representation of these semi-natural grasslands. But I think sort of biomass-wise, it's a quite small area that is currently available, and biomass-wise, we found that it's not really a lot of biomass from these semi-natural grasslands going into livestock feeding. So from that perspective, I don't know if the increased detail would sort of really change the biomass flows results a lot. But I think it's more related to this sort of what do we need to do to conserve the biodiversity in different regions and areas and different types of grasslands. But then to the lay cultivation, that is biomass-wise much larger and might also be counted as a grassland. So there we did some, we first looked at the national statistics, but realized that those are very low, apart from Denmark, where they were more reasonable. So there we made some efforts to try and do our best estimate of a potential yield in the lays. And also in the scenarios, we consider these lays to be well integrated into a cropping system and perhaps sort of managed closer to best practice. So we wanted, while currently many lays in Sweden are sort of managed more extensively. So there we looked at different field trials from different parts of Sweden and tried to correct the yields in the statistics. And there also sort of biomass that is grazed is not included in these statistics. So yeah, there are some biases in those. But I don't know how sort of close to the real potential yield we got there either, because I think it's really difficult with the grasslands because the statistics are very uncertain. Yeah, and I don't know if it could have been a better approach to use some more biophysical model to try and from climatic or variables model the grass yield. Might be a, I don't know, better way forward.
Well, it doesn't surprise me that you brought up the yield as one of the challenges, and that's kind of what I had in mind, but I thought I'll pose the question a bit more open. In terms of, you mentioned a semi-natural pasture that you had to estimate it somehow. What was that coarse way of dealing with it? You don't know, not in full detail, but just like a...
Yeah, we
give me an idea,
used,
like...
we used, now I might not remember exactly correctly, but I think it was from a report from the Swedish Board of Agriculture who had estimated some production potential, because they make these estimates on are there enough animals in this region to graze this. So we used some figures from there. So
good, thanks. That from my side for the second round.
Okay. Thank you very much. Then we leave the word to Professor Groth again here in the room. If you have any more questions.
Yeah, thank you. Yes, thanks very much for the opportunity. I have a few more questions. One effect is sort of more coming from a reflection based on the discussion thus far. And I think you are facing a sort of challenge in the sense that your work is very interdisciplinary, and you get questions on economy, nutrition, on basically sociology. Did you consult experts in these fields, or not, basically, or were there opportunities to engage with such experts?
No, not in the sort of field of more socioeconomic aspects. So we haven't, which I think the work would have benefited from perhaps being a joint work with some other PhD student more focused on the socioeconomic aspects. So no, we didn't have that.
Yeah. So I just wanted to share with you that many interdisciplinary scientists face that.
Yeah.
So I recognize that. Yeah. And then I have a question about your general discussion. On page 69, you talk about the land use leftovers, and basically, the difficulty in assigning, yes or no to particular land use. So can a particular area be used for crop production, yes or no? And then you sort of describe on that page 69 the difficulties or the ways that others have dealt with that. And then you conclude on page 70 with basically concluding that it's difficult to find objective biophysical definitions of land use leftovers. And my question to you is that conclusion now based on sort of your own data that you had and the difficulties you had, or do you think that this is a more general statement, or do you have some creative ideas to maybe make such distinctions?
That part of the discussion is not so much based on sort of results from my work, but more sort of when I've been thinking about this sort of moving forward, because in the Nordic scenarios, it was sort of there we assumed that these land use leftovers would comprise these semi-natural grasslands, and they were defined in terms of area. So there we sort of took that as land use leftovers, which is there are probably more areas in Sweden that might be called land use leftovers. So some of this that is called ley in Sweden might be in areas where it's challenging to produce annual crops for human consumption. But that is also very hard. Yeah, as I was discussing, it all depends on how much inputs you are willing to put in. So yeah, the discussion is more based on sort of referring to other literature and my thoughts moving forward with this. But I think it's as I'm writing, I think it's like it's a better way forward to think of where do we want grasslands and why, and if it's for sort of conserving biodiversity, or as Pierre was referring to, this including enough semi-natural land cover in agriculturally dominated regions and things like that. I think that is a better road to go to try and see, okay, how much, where do we want grasslands, instead of trying to estimate where we can't produce crops.
Yeah, so I think the difficulty comes from sort of the interaction between biophysical conditions, that may be too dry or too wet or too stony or other sort of conditions, and indeed the effort that we put into as farmers, for instance, in sort of intensifying the land use. That basically brings the difficulty, I think. Well, if I think, for instance, of the Netherlands, we have, for instance, peatlands that are naturally too wet, basically for cow grazing, because but now they have been drained and they are dry enough. Of course, the peat disappears slowly, but in principle they are not suitable for grasslands, at least for grazing. And so it's really that interaction probably that causes the problem. But if you would have maybe a biophysical survey or a metric, that you said, well, if you have to reseed your grassland every 3, 4 or 5 years, then it's probably also not so suitable to do it there. But yeah, those would be other approaches to it. Yeah, and then also in the general discussion, I move a page earlier, so page 68. There you talk about, well, your scenarios and that they take basically food production as a top priority, and then you come to a more nuanced sort of statement that you have to also include, for instance, bioenergy or other sort of purposes. On the one hand, that is of course a nice thing to say, also for the other interests. But on the other hand, you also know that you are sort of creating new trade-offs, basically, and that trade-offs are inherently difficult to overcome. So shouldn't we just say, well, most of the agricultural land, and of course there are exceptions, but let's say that the top priority is food production, and all the other things have to be sort of set aside and come later. But food production is number one, and all the other things have to find their own solutions. For instance, solar energy for energy or whatever. Isn't that a more constructive way to go about it? Maybe not a socially acceptable way at this moment, where we want to negotiate everything. What do you think?
Yeah, so I haven't really sort of, we did some bioenergy calculations in the Nordic scenarios, but I haven't really moved into the field of bioenergy. But like from my perspective, I think like we have several challenges in society, and one big one is phasing out fossil fuels. And like there are a lot of controversies if bioenergy should be a part of this phasing out of fossil fuels. But I think sort of the magnitude of that challenge, I think, needs bioenergy also. And it's also a fact that we do produce a lot of bioenergy today. So for, I think, around half of the rapeseed oil we produce in Europe goes to bioenergy. And you might argue that that is not a good way to go. But I think it's still something we need to consider. It is not a created trade-off. I think it's a real trade-off. And I don't, like, I wouldn't dare to say that we should focus on producing food on arable land, because I think we might need to produce energy also, because yeah, we don't only need to eat, we also need energy, and it's not certain that these other technologies will be able to scale up enough to sort of phase out fossil fuels fast enough. So we might need to rely on bioenergy also from agricultural land. So I think it's important to consider, with the risk of confusing.
Yeah. Okay. I understand your reasoning, and of course I partly agree. And in particular, in a sort of transition pathway, I can imagine that. But I think it then also builds a little bit on the ideas of a colleague of mine from Wageningen, and Martin Skepper, who says, in these kind of situations, you need what he calls integrative solutions. So solutions that completely turn the problem around, rather than negotiating the trade. But that's just one perspective. Thanks. I give the floor to the other.
Okay, thank you. Then we go back to Professor McDermott. Yeah.
Hi, thank you. I was just interested, we talked about reducing meat consumption, and this is a message that is going out, and as was mentioned earlier, is this a confusing message. But my question was really more around dairy. It provides very different nutrients, and I'm just wondering what your thoughts are on the balance of dairy and meat from ruminants, and what that would mean in terms of lands and crops.
Yeah, it's tricky. Like, from what we see, modeling, if we want to optimize the amount of edible protein that we can get out from available resources or leftover resources, then dairy production is much more efficient than to producing ruminant meat in terms of the nutrient payoff into the diet. But still, looking at the present situation, a lot of these landscapes that are like the semi-natural grasslands are often managed by the beef producing animals. But I think it's tricky, but I think what we modeled in the Nordic scenarios was a less intensive dairy production, where you would have more offspring per dairy cow, basically, or at least per liter milk, more offspring per dairy cow feed at least. So then you would have a system that is in the middle, producing still a lot of milk, which is efficient in terms of supplying nutrients to the diets, but also having these other animals that can do more grazing and contribute with these services. But of course, like, there are I'll stop there.
No, I was just interested. I was interested to see what the balance was, because, I mean, again, going back to the messaging, it does focus very much around reducing meat, and we are saying reduce dairy, but it's not quite the same emphasis of what we're proposing people to do.
I can just point out, like, in the Nordic scenarios, at least in the second one, where we used all the leftovers in the system, we ended up with around the same amount of dairy products in the diet, but still a lot less ruminant meat in the diet. So those results also point towards perhaps putting a bit of a more focus on reducing meat consumption.
And that I just wonder the implications of that for emissions. Did it make, would it make any difference that you've got more dairy cattle than beef cattle in terms of what you're then producing in terms of food and nutrients and things?
I will give maybe two different answers. Elin, my supervisor, made a previous study using the model that the Nordic scenarios was based on. And there she studied different scenarios, like if we would produce dairy or only beef. And there you could, of course, graze or more semi-natural grassland per unit greenhouse gas emission in if you only have beef cattle, while you would need in total more cattle to graze all of these areas if they are in dairy production systems. But then if you would measure these emissions per unit animal source protein produced, then you would have lower emissions if you have a dairy system. Was that the question?
Yeah. Okay, thank you. Yeah, so we want to move on to the next.
Yeah, okay. It's up to you if you want more question, or otherwise we come back to you if you have more later on also.
Well, my only other question was really about what would this mean in other regions of the world, sort of not necessarily sort of very low income countries, but is what you've done sort of applicable to other parts of the world where this could be a similar setup in terms of the balance of what food and ruminants, etc., could be produced? Or is it very specific to the Nordic countries?
I think like it's sort of grasslands differ a lot in different regions of the world, both how much there is of them and sort of their biodiversity values and things like that. So in that sense, it's more sort of, I don't know, pertains to the boreal region of Europe maybe. But a bit more general, I think, sort of the main sort of directions of the results would apply to other high income settings like the United States or Canada and Europe, of course. And on purpose, I didn't go into sort of other regions of the world, partly because I'm not well familiar with agriculture there, and sort of there are a lot of different problems with diets, and in some regions you might want to consume more animal source food to improve nutrition status and things like that. So like the results, I think I write somewhere in the thesis that it's sort of a Northern European perspective, and I think that is sort of where the results are applicable.
Okay, thank you.
Thank you very much. Then we continue to Dr. Harder.
Thank you. One more question I would like to again go back to was one thing that has already been touched upon in the discussion between you and the opponent. That's the leaching of nitrogen from agricultural land and grasslands. So I remember that in your thesis you explained that in principle organic farming would have less losses, but you haven't accounted for that. Then there is another assumption that you made regarding to nutrients, which is that food waste, manure and biogas are fully recovered and reused. And that assumption is kind of, I thought it was mentioned like en passant. And now in your presentation, you said it was optimistic. My question now is, how realistic is it?
Yeah, so like for manure, we assume a full recovery, and also that all of it goes through a biogas digester, which is highly challenging, as you would need many biogas digesters distributed across Sweden to collect all the manure and then distribute it back. So I think that assumption, sort of making bioenergy from all the manure generated, might not be very realistic, but I think returning all manure to arable land is less of a optimistic assumption. I think that is feasible. And regarding food waste, we have assumed a collection of 80% in the scenarios. And I know today it's around 40%, I think. So that is also like a very challenging transition to manage to collect all those that food waste. So yeah, those are very optimistic and maybe currently not realistic scenarios, but in the future, I think we need to transition towards trying to recirculate all nutrients, and I don't think it's really unfeasible to collect 80% of the food waste if we really try.
So in terms of the manure, is that mostly because you are drastically reducing intensive production systems and therefore like the spatial disconnect between land and animal systems? Is that the factor that mainly helps to make you confident that all the manure can actually be returned?
Yeah, like in the scenarios, our assumption was sort of a more evenly distributed production systems, including lay in most crop rotations. So then likely also having livestock on much more farms, but fewer. But in the scenarios, we didn't really go into any spatial detail. Right. I know there has been a paper who explore sort of the spatial details, including the biogas production associated with these scenarios. So taking our scenarios and then trying to spatially disaggregate them. And unfortunately, I haven't gotten to reading that paper yet, but I think that might be interesting. And I think they might detect some challenges with sort of how can things be spatially arranged in order to make this work. And I think you will run into problems there also with the feasibility of these scenarios. Yeah.
I think you're referring to the work of the people at Linköping University, Metson, Akram, etc.
Yeah, exactly.
Yeah, that would have been the next question, whether you have looked at that. We'll skip that. Still with the assumptions. You also, if I remember correctly, say that for human excreta, I mean, that's something that interests other people in your research group. There is 50%, if I remember correctly. So what makes the excreta more challenging than the animal manure, so that the assumption is so very different? Or what makes the animal manure easier? That kind of motivates this 50 or like factor of 2 in the assumption.
Yeah, to be honest, this 50% is, this is only in the thesis, not in the papers. And to be honest, I sort of just wanted to give something to indicate some possibility there. Right. But I think inherently manure is easier to recirculate because it's on the farms, while human excreta is in the cities. So I think there is a difference there in the challenges. But this 50% was to be able to plot something to show sort of the potential.
Good. I have one more question, and that's about the transferability of your model. And now I'm speaking purely of the model and not the results and the conclusions. So how easy would it be to apply your model in a different European country? I'm like thinking of the structure of the statistics, etc., the input data. Like, is it just like plug and play, or is it not that simple? And also another dimension of transferability, and that's kind of based on the observation that some of the details were inherently hard to find. I found them hard to find in the thesis, but also in the papers you refer to in the supporting information. So it was a bit of a struggle. So I'm wondering, like, maybe this is even on purpose that you're not disclosing everything in detail. I'm not sure. So the question is, how willing is the research group to make this model available for, say, another research group who would like to do a similar study in another country? So it's one is the technical part, but the other is like the more soft part of the transferability.
Yeah, I think there is a lack of transferability in the model that we used in the Nordic scenario diets. And I think, there are a number of reasons. Like, it's been sort of a learning process for me. And I think sort of my description of methods and sort of making data available and things like that is much better in the fourth paper than in the first papers. So I hope I have improved on that regard. And like the transferability of the model, it's sort of built in an Excel sheet. And I took the model from my supervisor initially, and then further developed and built on it. And so it would be possible to use it and plug in other data for yields and areas and things like that, and do modeling with it. But yeah, I don't think the transferability is great, unfortunately. And this is something I really have realized during my process and will try to improve on in future projects. But I would, of course, be willing to share the Excel sheet if anyone would be willing to put the time into understanding it. But so yeah, I will be involved in a modeling project here in the future, and there we have a much higher ambition of creating a model that is more sort of modular and possible to extend, and I hope that will give some good results and a model that is more easy to share.
Thank you. That were all the questions from my side. Thank you so much.
Thank you.
Thank you very much. And I ask in the room also, do you have any more questions?
No, thank you.
Okay. And Professor McDermott, have you any more questions?
No, I haven't got any more questions. Thank you.
Okay, so thank you very much. Then we continue with the people in the room. If there is any questions or things that you would like to highlight. Yeah, please.
Yes, I have like 2 questions. I've been following you for the last 4 years in your work. Thank you for the interesting presentation and discussions. As a professional, I work with land use policy and built environment policies on the municipal level, regional level. And so to my 2 questions is, I remember early in your work you studied like the possibilities to be more self-sufficient on a regional level in food supply systems. So regarding our work with land use policies or city development, is there any do's and don'ts, some important decisions you think you can highlight in that area? That's one part. The other part is like, of course you focus on the rural areas and farming land systems in your thesis and your work. But the other part of the system is the city, where a lot of people live and consume what's produced in the farmlands, but also produce like waste that are also resources into the farmland systems. And are there anything we need to highlight in that to improve the full system of food use and reuse?
Yeah, I think sort of the last part first. I think the nutrient technology group here are excellent people to talk more about the challenges and possibilities of recirculating more nutrients from the cities to the field. So yeah, I don't dare to say so much about sort of what barriers needs to be overcome there.
But I think it needs to be done something.
Yeah, I definitely think that we need to to be able to phase out a part of the fertilizers that we apply, for instance. We really need to increase the circulation from society, and also to avoid problems with eutrophication and nutrients ending up where we don't want them. We can also help that by managing the flows to end up where we want them. So I think it's a really important thing. And with the do's and don'ts, I'm also not sure, and my head is starting to get tired now. But yeah, I don't know if you're referring to this sort of should we exploit arable good fields for settlements or not?
Do we need more policy on the regional level, how to use the land, or don't use the land, to keep the possibilities open of being more self-sufficient on the regional level? Maybe a tricky question, 4 o'clock in the afternoon.
Yeah, sorry.
Okay, thank you. Continue, Jennifer.
So thank you. It's been a fun afternoon listening to you in the discussion here. I had a question a bit on the same lines, actually.
Maybe you can answer Roman's question.
I know your work has been on sort of landscape management, but you have also been looking into the production of food, adequate production of fats, proteins, and nutrients. Have you also considered potentially other sources of fats, proteins, that there's movements for insect production, or I mean, what you've been looking at has been very much sort of conventional agriculture, and how can we do it differently? Did you at all consider in your scenarios this introduction of potentially other sources of fats and proteins, or production on non-arable land in cities, for example, like hydroponic production of vegetables and such? So did you consider those at all, and why or why not? And more from a personal perspective, do you see those actually, to what extent do you see those as actually part of the future of food production?
We didn't consider these more novel protein or fat sources. And it was in the Nordic scenarios, it was a deliberate choice sort of by the NGOs that we should focus on scenarios of sort of more traditional agriculture, so not going into these more technological systems. And they were sort of more talking about sort of agroecology and sort of this. So there it was a deliberate choice not to go into those more technical systems. So I haven't done anything in that line. But the most innovative sort of system that we included in the scenarios was Nile tilapia aquaculture in tanks, since this is sort of fish species that can be fed on plant-based fish feed. But apart from that, I haven't looked into sort of insect protein and the potential for that. And regarding urban agriculture, I haven't really done too much thinking about that either, but I sort of have, I can imagine that it could be a quite sort of large contributor to vegetables, for instance, but on a more sort of bulk feed, bread, cereals, things like that. I don't see sort of cities being the thing that makes us self-sufficient in food, but on the more vegetables and things like that, I think it can really, and I think it can be an important, I don't know, reconnecting with the food thing, sort of a more social aspect of it, bringing more of the production into the cities to sort of connect people with their food a bit more.
Thank you. Any more questions in the room? Is there any questions online? Edith, do you have track of that? Okay, so thank you very much. It's been really interesting to listen to this discussion. I mean, it's been a good sort of discussion on the livestock, if it's how it should fit in future food systems. It was really interesting to hear, and also hear your perspective change from the livestock to the landscape, which I think is really a good way of moving forward also with the research. And we heard the opponent bring up that it's a global discussion if the ruminants should be there for greenhouse gas emissions or not, and that it's actually, this is really relevant for the discussion about the future agriculture today, and also the environmental impact that we have from society. And we heard that grassland modeling is really difficult. And then if it's semi-natural grasslands or permanent grasslands, that was also one of the questions that was brought up. And it's also, I learned a new term today, which was quite interesting to hear, nitrogen-based livestock. That was, for me, it was very new. And we heard also the same, for the same animals, it's monogastric or white meat animals, which is quite interesting, and it shows different views of the topic. We also heard a discussion of should we really focus on protein and fat, which has been sort of the framework of your studies, or is it actually other micronutrients that is more important, with like vitamin A, zinc, iron, and so on. And then we have the continuous discussion on phasing out fossil fuel and bioenergy and food, how they should fit together, which is quite interesting discussion also. And we heard also discussion about the model and the transferability of the model, and if there is interest of sharing the model, or if it's possible to share the model. And the final question I would say that is sort of coming out of this, what is the best system? Which is really, really tricky to answer, I would say. So with this, I would thank all participants here and closing this session with an applause.